Hello. Well, hello, everyone, and welcome to today's series of talks here at the Aleph de Verano Hackathon. My name is Anna, and I'll be your host for these incredible sessions today. These talks of today are designed to give you valuable insights and hands-on knowledge tailored to the different tracks you have chosen or are interested in. So let's see the schedule of today. Let's see the agenda. Well, first we will have confidential smart contracts on Ethereum by Sama. Then we will have at 12 p.m. building on-chain with a little help from AI with Austin Griffith. Then at 1 p.m. we will have building Web3 apps with Web2 UX on zkSync, of course by zkSync. Then we will have Superchain, what it is and what it needs by Optimism. And finally, we will have what the fuck is zk hands-on workshop. So first, we will have confidential smart contracts on Ethereum by Sama. Here we are with Aurora. She's a dev reel at Sama. And well, welcome, Aurora, and it's all yours.
Test, test. Can you hear? Hello, can you hear me? Okay, I don't know if it's working or not. Nobody gave me any heads up for this. I will assume that it's working. Let me get some confirmation. Can you hear me? Okay, it's working. Good. We got a confirmation. Good, good, good. All right, all right. So let me present my screen. So my computer, I have no slide share screen. I didn't see this interface ever before, so I'm sorry for. Okay, right. Hopefully this will work. All right. Yeah, you should see a mirror effect right now. Okay, so let's get started, right? I'll be with everywhere. All right. So, confidential smart contract on Ethereum. Okay. You are here probably because hopefully you are in the hackathon and want to learn more about Zama and want to learn more about what we're doing and want to participate in this great hackathon and maybe even go for the FHE track. And although FHE sounds super terrifying and super daunting, it's not. And we're gonna cover all the basics here. But before we do, I just want to show you first. So let's go here. All information that you will need for us, we will try to put in the, if you are already in the Hackers Aleph de Verano channel, all information you will need is here. So here are our little bounties. There is more information. I will quickly show you where. So here you will have also some information. We'll be posting more where we are, who we are, and so on. They should share the link for the workshop. So yeah, okay, good, great. Anyways, and the more information you can find is actually here. Let's go here. Yes, on the Zama bounties. I'm going to share this link quickly with you here again. So if you go here, Zama bounties, you can see and you can read what are all the bounties, where are support hours, what we can do, what kind of things we expect of you, what is the first prize, second prize, third prize, all the possible applications you can have. And if you want to go outside of this, of course, it's possible. You can just come to us and ask what is going on. Anyways, then we have integrating FHE in other applications. This can be anything from MetaMask, Snaps, and so on. And we will be super happy to have something there. And if you want to see, this is the general judging criteria. And most importantly, I want to show you some resources already right now. I will repeat this again on the end of the workshop. You can dive into Zama's documentation. This is the best resource you can get. So docs.zama.ai FHEVM. Here we have basically all the guides. It's quite extensive. So anything you'll need from smart contract development and so on, architecture overview, how to write your first smart contract, using Hardhat, using Remix, and so on. You can find all resources you need and want here. Anything that is not there, we will post it, and you can come to us, of course, or actually, even better, write to our Telegram chat. Next up, we have as a really good resource our Zama Solidity developer. So you can check it out here. This is a custom ChatGPT that was trained basically on the resources that we have. And I cannot sign up here because, wait, let me go into my personal account. It's over here. And if we go to Zama Solidity Dev, you will be able to see the internet is a bit lagging here. So sorry for that. Anyways, you can ask it to basically create a DID smart contract, and you will get a little overall outline of how the code looks like. And basically the idea is here not to use it word by word, because this is not the best, but just use it as a template for you to get started. It will basically cover all the basic concepts. If you'll use this, it's not the most secure, so don't use it as is. Use your own head as when you are using this. All right. Cool. All right, let me see if there are any questions on our call. Everything seems to be in order. Let's start with our workshop. All right. So, confidential smart contracts on Ethereum. I'm going to be a bit walking because I can think better like this. So, confidential smart contracts on Ethereum. What do we think? What do we want to say about this? And what this workshop will contain? So, we don't have that much time, so our agenda is going to be much quicker. We're going to do a quick intro, a very quick architecture overview. We're going to dive into smart contracts, and we're going to basically do an example project. So who am I? My name is Aurora Popici. I'm a developer relations at Zama, and I joined Zama recently. I have participated in many hackathons, and at UCC and U Singapore, we won. We were one of the finalists. And I began working in blockchain space in 2022. So it's been about, 2-3 years right now. All right. So let's get into the title. How to do confidential transactions directly on Ethereum. What do we mean by this? I mean, confidential, what is even confidentiality, you would ask, right? Confidentiality, privacy, isn't that the same thing? Well, here I'm going to be a bit boring, but kind of the definition of privacy is basically we refer to privacy when we're talking about rights of individuals. And then we're talking about confidentiality when we mean when we are referring to obligations of those who manage information. So these are basically legal companies. This is a lawyer's obligation to the client. This is doctor's obligation to the info. And the encompassing thing that is commonality for both of the two is basically protection of sensitive information. Why am I saying this? Well, because when you understand what confidentiality means, you understand, well, before, everything on Ethereum, everything on blockchain is verifiable, right? But it's public. And because it's public, in that sense, we cannot have confidentiality. We cannot ensure, we can basically not have as many applications as we want because there is no confidentiality, there is no privacy. So what can you build at this hackathon? Well, there's a lot of different things you can do. As we bring confidentiality to the blockchain, we can have tokenization, we can manage swap assets, tokenized assets without others seeing it. We can have blind auctions. We can have on-chain gaming. We can have, finally, confidential government voting. So you can actually, before, you couldn't actually have government voting online. Now, with confidentiality, you actually can. You can have encrypted DIDs. Whoever is going to do something like that, this is a very good application. Assisted with maybe zk or without zk, it can actually basically make information much faster, and all sorts of kind of financial, like old financial applications, which are super boring but super essential and are just waiting for us to take them and to automatize them. So you can use FHE here. All right. So you will ask yourself, okay, what do I, as a person, need to know about FHE to get started? Well, the answer here is not that much, right? You have the public key, the private key. You already know this concept from before. There's always some public key and private key. What does the public key do? It encrypts the information. The public key is available basically everywhere. It encrypts the information. The private key, what does it do? It decrypts information, right? Before it was in encrypted format, now it's in the decrypted format. So private key is only only available in some single entity has it. In this case, we will see the architecture a bit later, where the private key is held. Well, one of the differentiating factor in the FHE is that we also have an evaluation key. What does this mean? So if we have an encrypted EUINT, encrypted basically integer, and an encrypted integer of another sort, we can do multiplications, we can do additions, we can basically do computations on encrypted data. So how does this look like in practice? Well, a stupid example is, well, you have an encrypted 2 and encrypted 5, let's say, and what is the result? An encrypted 7. Everything is encrypted, but all the computation has happened on the background, right? And what is another application, you might ask? Well, let's say for a DID, I want to drink some alcohol, but I don't want to reveal you how much, basically what's my age, right? Because we all know you should never ask a woman about her age, right? So, so what do is basically I encrypt my information, I encrypt my age, and then there is a encrypted 18 as well. And this is compared to my age, and then an encrypted Boolean, which is a result of this computation, arises. And then basically we figure out if I am allowed to drink or if I am not. All right. Okay, this is the biggest hefty part of our infrastructure. And it's important for you to kind of understand roughly what's going on, mainly because when you will be developing smart contracts and the dApp on the front end, you will need to know what's going on so you can kind of have a better understanding of how to approach things. There is a concept we call, in the blockchain space, we call it symbolic execution. That's what we are doing with our FHE-VM, which is basically the application of FHE on-chain. Symbolic execution, what does this mean? Well, it means that we have a pointer that is pointing, so it means that basically everything that is stored on-chain are pointers. So let's go and here, don't mind the title, we're going to create a new node. So we have basically on-chain, what we have is a pointer. So as you know from maybe C++, this is like something like this, right? So on-chain we have a pointer. Okay, this doesn't work like so. All right. Yeah, they don't like the asterisks here. All right, pointer. So on-chain we have a pointer, and this pointer is pointing where? It's pointing to off-chain computations. Why? Well, so we have off-chain, and there's some values here, right? So we call this pointer also as a handle, and this pointer is basically pointing to values that are off-chain. Why are we doing this? So all of the computation is actually happening off-chain, as we say. If FHE is actually quite a hefty, quite a computationally expensive process, that's why we want to have all those computations actually performed off-chain. So on the coprocessor is basically the one that is doing all these computations. And then here you will see something called the gateway and the KMS. Those of you who are a bit more familiar with some FHE, you will know that always behind the scenes there's some multi-party computation, we call it, right? And this is basically the splitting of keys to multiple parties. And this is what is kind of going behind the scenes, one of the parts that is going behind the scenes in the key management system. So this key management system is the one who holds the private key, right? And also the coprocessor is basically has the evaluation key, so it can do computations, right? Now, when we have when we are basically developing smart contracts, we are doing two things. We are doing things on the dApp frontend, and then we are doing things on the smart contract side. So we're deploying smart contracts. So these smart contracts, which you will deploy and create and hopefully be successful at it, you will be, because no worries, it's not so hard. They will be communicating with functions that are deployed on FHEVM smart contracts. So FHEVM smart contracts have have also a public key there, and you can basically do encryptions there. And also this public key is also available on the front end. Anyways, let's go. Let's roughly, this is kind of the architecture we're speaking of. Let's dive now into smart contracts. So we will go a bit more into details into each one of these sections later. So let's dive into smart contracts. So here I prepared for you actually a counter.sol example. And as you know, every time we encounter some sort of basically introduction to something, there's always a counter.sol. Our counter.sol will be different. It will be what? A confidential or encrypted counter.sol, right? All right, first let's see what are the supported types. First, I want to see if you guys have any questions. There's no questions here. Okay. All right. So, what are the different supported types? Here we have encrypted Boolean, encrypted EUINT4, encrypted EUINT8, and so on, to e-address, e-bytes, and so on. These are not supported, but will be coming soon in the future. So, anytime you basically, those of you who are very familiar with smart contract development will see that these types are very similar to normal definitions. They just differ in the fact that they have E in front of them. So E as encrypted Boolean, E as encrypted EUINT4, right? And there's few rules that maybe you would like to follow. Anytime you have some strings or some bytes information, it's probably better to use e-bytes. Anytime you have an address that you would like to encrypt, so you wouldn't like to disclose somebody's address, for example, you would use e-address. And then for EUINTs, the thing that you should follow is store as least amount of information as you can. So use the smallest type, use the smallest type as you can. So for example, let's say I want to store my own personal age, right? And we actually, which type would we use, right? So my age goes roughly from 0 to, I think the oldest person in basically lived until somewhere around 120, right? So here, if you guys would be live, I would ask you, well, what is the correct type that we should use? And the correct type here, as you would guess, is EUINT8. Why EUINT8? Because EUINT8 goes from 0 to 255. You wouldn't use something like EUINT 256. It doesn't make any sense, right? All right. I think you will kind of get it. If not, we are there available and you can come to us. All right. Let's see. We have a list of operations. And here I have to switch these two. Finally, I remembered now. Let's present. Okay. So, sorry for that. So we have the list of different operations. We have bitwise operations. So we have AND, OR, XOR, NOT, and so on. And then we have arithmetic operations, which I showed you before. This is all done with this evaluation key that we were speaking of. And so here we have addition, subtraction, multiplication, division, basically reminder, negation, minimum, maximum, and so on. And then we have comparison operations, which is where you would compare basically if my age is greater than, let's say, 18 or not. And where you can get all this information, let's just look at again. This is all in the documentation.zama.ai/FHEVM. All right. All right. So one last thing. Well, there are many more things, but one of the operations I want to point to you as well is here rand EUINT X. So this is basically a random EUINT that you can use in your applications if you're doing something with gambling, if you're doing something with, let's say, a lottery or something like that. This could prove very useful. All right, let's now check this cycle. So this is a bit section from here. This is this part over here. So from DApp smart contract, FHEVM smart contract coprocessor, what happens exactly behind the scenes? So when you're doing computation of encrypted data with these operations that we've been mentioning here, actually all of them, you are basically communicating first. The DApp smart contract has a function, so is basically calling a function that is available in FHEVM smart contracts that are already deployed on chain, on Sepolia Ethereum. And this is basically sending a command to the coprocessor. The coprocessor does the computation completely asynchronously, right? And this coprocessor then stores this information on the database. So at no point is basically this returned to the FHEVM smart contract. On the FHEVM smart contract, we said there's only the pointer. So off-chain are actually values. All right, this is kind of it. We're not going to go into details because we don't have so much time. Anyways, so when you will be developing with smart contracts, here's kind of the configuration that you will need to know. So always you will configure your smart contract with something like this: FHEVM config Zama FHEVM config.sol. That is all that basically you need to add to your smart contract. And then we have something called ACL. So this is access control list. Because in the concept of FHE, you actually don't want everybody to access the information. So if you have an encrypted value, you don't want everybody to access it, right? Because if you want everybody to access it, what is the point, right? I mean, then why would we need encryption in the first place? So that is why we use something called the ACL, or access control list. That basically means that we can allow certain addresses, to decrypt this value. So in this case, we have tfhe.allow. We allow the message.sender to have access of this temporary value. Then with tfhe.allow this allows the contract itself to use this value. When we say use this value, it means not only using it as decryption. In the case of smart contract, it's a bit hard. So don't think about, oh, a contract will access my information. No, it won't. You basically will allow the contract to do computations on this data, right? Then we have tfhe.allow transient. This is only temporary usage within the transaction. You can check in the documentation for more information. All right, cool. Let's go now that we have all this information. Let's go to our counter1.sol example. So we have here sample one smart contract that we created. As you can see, it's very similar structure in the start as we said before. So we have contract encrypted counter1 is Sepolia FHEVM config, right? And then we have basically we initialize our counter and we initialize our constant. This is basically constant 1. Then in the constructor, we're initializing the counter with an encrypted 0 value. And we are allowing this basically TFHE to use this counter. So as you remember, as we said before, we have to allow the contract to use the value itself. Then, because we want to also specify and save on gas, we specify basically this value. Behind the scenes, this is called trivial encryption, and it's not really encryption as it is, because we already know what the value is. So it's not real encryption, right? And we again specify and allow the usage of this value. Then we have our main function, which is called increment. And basically, when we are calling this, we are performing the computation. The computation, which, as we said before, is happening on the coprocessor, right? So, and then we are allowing again for this smart contract to use this information. All right. So, fairly simple enough. You might ask yourself, okay, so how can we do this? And this doesn't seem right? There are some things missing on this contract, exactly. There's two major problems with this contract. First, let's see how we can test it. So tests are very simple. You can see, so with the resources that we shared with you, you can check over here. You will see something called React FHVM hard hat template. If you go here to our repository, this is a very nice hard hat template that can get you started, and it's so far the most kind of used thing that we use now for making smart contract, and is the best tested. So please, when you're developing your smart contract, use the hard hat template. All right. So, all right. So this is from Hard Hat. So we initialize the stuff before each smart contract. Before its test, we want to deploy a smart contract, and then we basically call the function increment, and that's about it. All right. So there are two problems with this contract. Well, the first one is we cannot see the value. I mean, what is the point of this smart contract? We cannot even see who it is. Yeah, okay, the smart contract itself can perform computations on it, but I mean, we are real people, right? We are not a smart contract itself. We actually want to know what's the encrypted value. And then there's another problem. Nobody can do inputs. We can look on chain how many times the increment function has been called, and we can see the value of counter, right? So encryption in this case of the smart contract defeats the purpose. All right, so let's go forward. We have to introduce several new concepts to our smart contract. One of them is encryption. As we mentioned before, if you remember this schema, we are using for encryption the public key. So the public key is basically doing what? It's actually encrypting the information. So this is how you would send an encrypted input as a user to the front end. On the front end, you would input something like this. You would say, create encrypted input. You would add 8. You would add basically, this is a EUINT 8, and you would add basically 5 to it. Then you would encrypt it, and you would call the function increment by. All right, this is fairly straightforward. So one thing you have to know when you're doing encrypted inputs, you want the user to encrypt it already on the front end. You don't want to do this basically on the smart contract. It doesn't make sense, right? Because once you do it on smart contract, everybody can see this information, right? So on the smart contract side, this looks like something like this: increment by input amount, and then we have something called input proof. You can look a bit more into it what does this mean? Fortunately, we are running out of time, so I cannot explain to you, but it's basically something to do with zk proof. All right, so then we have finally our encrypted amount. So this is our sample.sol, and we basically replaced our function increment with this function increment by. As you can spot here, there is similar as we defined here. We defined increment by and input proof, and basically we are storing this information on chain. All right, so our sample2.sol sample2.ts looks something like this. We create an input for amount to increment by, and then we call increment by with encrypted amount. And then you will see something here called handles, and this refers to what? The pointer that lives on chain. All right. Okay. Cool. Let's go forward. Still, we don't have the concept yet to see this information. So we need to introduce something new. We need to introduce decryption. All right. So decryption, if you remember from our architecture schema, we have basically something called the KMS in the background. So we have what is happening. We need to basically call a decryption request. So the decryption request is basically calling the gateway, and the gateway is basically acting as a relayer, calling the KMS. So if you look here a bit more in depth, our DApp smart contract basically calls a function on the FHEVM smart contract, triggering the decryption, and then the FHEVM smart contract trigger gateway, and then our gateway triggers basically forwards this request to the KMS, and then the KMS finally decrypts this information. So when you are performing the decryption, you basically have to configure it in a special sort of way. You have to add two new imports that we are adding. We're adding Zama gateway config and the gateway caller. And in the contract, we have encrypted counter free, Sepolia, Sepolia Zama gateway, gateway caller, and so on. So this is our configuration. And in the decryption example, we are basically having, this is basically an asynchronous process. So what does this mean? We have, so as you know, because we are doing this, so this FHEVM smart contract are not performing this, right, action. So we are triggering we're putting an event, the gateway is actually monitoring it behind the scenes, and then this is executed by itself, right? So that's why it's an asynchronous process. It doesn't work instantaneously. It's basically we have to give it a callback function. So basically here we are basically calling the gateway dot request decryption, and we are sending it a callback selector, and this is our callback counter. And what you have to know when you will be using this, you will basically be making the value public for all and posting it on chain. It will be visible for everybody. All right. So our counter free.sol, let's go quickly through it. So this was the function so far that we had. These are the functions added. And basically, so we are requesting the decrypt counter, and then we are passing the callback counter, which is only available to access from the gateway. So only the gateway can call this function. So we are passing in this function to our request counter, and then after the process has decrypted, we are requesting to get the decrypted counter, which is a value, is the value EU int 8, not EU int 8. So it's decrypted already, right? So similarly, on the sample3.ts, you will see that you basically are initializing the gateway. And then you are basically, so you're calling for request decryption, and anybody can call it. Here you can see the signer, Carol, is actually calling it. And then we are actually waiting for decryption to complete. So we are waiting for this process to complete. And then we are tracking if this decryption value is correct. So this should be equal to 5. All right. Now, we said this value is public for everybody once we do the decryption. What if only Bob? What if only Alice? What if only Carol wants to see this information? And Carol doesn't want Bob to see this information. Okay, what do we do then? Well, we can have something interesting called re-encryption. So what re-encryption means? Basically, it means that we are encrypting we are decrypting something and encrypting it back into something else. What happens here? So when we are triggering the process for re-encryption, we can only perform this action on the front end. So our front end is calling the gateway, and the gateway is relaying this information to the KMS. So the KMS sees, okay, this person is authorized to actually access this information. We should probably show it to him. What happens, so the KMS then, basically KMS decrypts the information. So the information is visible, not really. And at the same action, encrypts it with the user's public key. So we are using the private KMS key to encrypt the information, and then we are decrypting it with the public user key. And then we are sending it back to the DApp frontend. And because the user, as we know, the user has the basically private, he has its own private key, we can actually decrypt this information. So the code is quite hefty here, but you will see this is just what is going behind the scenes. You actually don't need to look at this. We have actually we have a few steps that you just need to kind of know. So we have basically, we're generating the public and private key for the users. We are creating an EIP 712 object. We are requesting user signature. We are getting the ciphertext, and then we are performing the re-encryption. All right, so how does this look like in practice? Here we change our sample 4.sol a bit. So we have encrypted counter 4.sol, and this is basically follows a similar configuration as we've seen before. However, you will see here there's a bit difference. I changed the contract a bit. We are allowing each user to have their own counter. So each user, so mapping to address EUINT8, you will know means basically you have each address can have its own EUINT8. So each address will have its own counter. And then we have this increment by function where we initialize the counter. If the counter doesn't exist, then we are converting EUINT8 to sender's counter. Then we are basically adding this information together. We are allowing access to this information to the smart contract so it can perform the computation again. We are allowing access. We're allowing basically access to this counter to our message.sender. And then, of course, when the person wants to access, wants to get this value, we just return this counter message.sender. We are returning here. It's a difference. We are returning encrypted EUINT8, right? So if our message.sender actually has access to it, he will be able to see it. So if we go to the front end or test in this case, this should look something like this. we have, we create an encrypted input. We add 1 to it, as an example. We encrypt it, similar as before. Then we call encrypt by, similar as before. And then we are getting our counter from here. And all you need to do, it's unbelievable, all this information is abstracted away just by calling re-encrypt EUINT8. So by calling re-encrypt EUINT8, you actually do all these steps that we mentioned here before. So you generate public and private. So no, sorry, this has been already generated. Yeah, this has been already generated. You create an EIP 712 object, you request user signature, and so on and so on. And then basically you return it. All right. So now I don't know if we have more time. I don't know if we're running out of time or not. Let's see. I don't think so. How do I know if we're running out of time or not, actually? Are we running out of time? Okay, I don't know. Let's see. All right, so here again, all the resources you will need. I will just repeat the resources. We're not going to go more into details about our confidential ERC20 contract. If you want, actually, if you want to do something with confidential ERC20, we made a really nice example. We made a really nice and hefty project with all the different, let me show you. So here, if you go on FHEVM contract, these are all different contracts that you can basically use to help yourself. So these are meant to be to act as extensions. Here you have the token, the ERC20, the confidential ERC20 token. You have different extensions, the mintable. This is very similar to what you see with EIP standards. You have different government contracts, and the idea for you when you will be using this is just to extend it. So when you will want to use something called confidential ERC20, you will just be extending from FHEVM contracts, and you will be extending this confidential ERC20 mintable.sol. So this is really nice, and you won't basically, you don't have to create everything from scratch. The idea is for you to just extend it, and voila, you have a confidential ERC20 token that's available for you and you can use. So that's as simple as it can get, right? I think this workshop will be actually basically recorded. So hopefully it's recorded, and you will able to see it. But anyways, just once again, for me to repeat you, here are all the things that you need to know. And please come to our Zama group to ask us questions. We are available here, and we actually will gladly offer you support. People are available for quite a lot of time, from 8 a.m. to 8 p.m. And if you want to, basically, you can either come to us, brainstorm ideas. I think Clement has been offering some times for you to also discuss the projects. Here you can see will be available on Zama, Discord as well. Yeah, but you can ping Clement if you want to actually discuss in depth what is going on. And so here you can see all the possible information that we have, if we, so prizes and so on. And then here you can see our development template. One of the things I will mention to you a bit more. Here we have a really nice React template that has been recently finished. So you can basically learn how to deploy in Sepolia. You can use it in mocked mode. What means mocked mode? It means that you can use it off-chain. You don't need to actually, because Sepolia is quite expensive, as we know, and as a lot of hackers will be using, you will see it will be some computations are quite expensive. So when you will be working with your smart contracts, you can use mock mode. And then basically, so here you can also use this is basically maybe currently now the best starting point for you guys. Develop your smart contract in the hard hat template, and then once you can just put pmpm deploy Sepolia or pmpm deploy npm. Sorry, let's see the commands now. They are updated. You will just basically run npm. Don't run pmpm. npm run. Then you'll have a hard hat test, and this is the command you have to run: npm run deploy Sepolia. And if you want to basically start the hard hat, you basically start this with npx hard hat. All right. So when npx hard hat is running, then you can use the front end as well. You can install it, you can basically run it, build it, and so on. And it will listen on the local host 4,173, and so on. All right. Hopefully, are there any questions? This is not here, and there is no comments. I don't know, maybe this is not working exactly right, but I'm gonna slowly stop sharing. I think my workshop should stop right now. And should I just leave the studio? I think that's gonna be okay. Yeah, please leave questions in the Telegram group. Here. Yeah. Yeah. So people have some trouble entering. So I'm so sorry about this, but I think this is being recorded, and you will be able to see this later on. All right. Thank you for participating. Thank you for listening to this workshop. I'm super happy to be here. Again, if you have any more questions, come to us, come and ask us, and we'll be here and we'll try to help you. Don't be one of those people who are asking the last minute on how things are working. If something major breaks, we hope that it doesn't, but inform us as quickly as possible. We will try to resolve it. We are here available for you guys, and we are available online as well. We have a team basically on site, on their computers, ready for the whole weekend for you to basically, if you have any questions or if there are any errors that come up, we're here to help you resolve them. All right, cool. Thank you for listening again, and bye. I'm going away. Enjoy your rest of your day, and happy hacking.
Thank you, Aurora, for your time and sharing your knowledge. And also, I want to remember to the participants of the Aleph de Verano Hackathon, if you have any question, contact us on Telegram, and we'll be happy to assist you. And now, well, in 5 minutes, we'll be with Austin Griffith in the next talk. So stay tuned, and we're back in 5 minutes. Oh, sorry. Welcome back. Welcome back. Now we'll be talking or listening to Austin Griffith. Austin is the co-founder of BuidlGuidl, which is a community of builders creating innovative on-chain projects and tools. So today we'll be learning about building on-chain with a little help from AI. And remember, if you have any question, you can send it on our Telegram, and we'll be happy to answer it as soon as we can. So, well, Austin, welcome, and thank you for being here. The stage is all yours.
Oh, there we go. There we go. Okay. Hi, everybody. What's up? Boop, 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 boop. Can I share my screen? I got a screen set up. Can we get that added in too? I wish I could see everyone there. I can't see anyone. It's too bad. I'm going to be shouting into the void here, aren't I? There we go. Okay. Everything good? Everyone hear me? Everything okay? All right. Awesome. Yes, please ask questions. Like, this should definitely be an interactive session. If you have any questions, I have no idea who's on the other side of this. I'm just shouting into the screen here. So please, reach out, ask questions. I'm not even sure how I see the questions, but I will try to keep an eye on it. I don't know. Oh, maybe it's over on Twitter. Let me get that set up real quick, just so I can see it, because I want to be watching for questions if there's questions. But today we're going to build something. We're going to look at Scaffold-eth, and we're going to look at how you build things on chain, and we'll probably use a little help from some AI. Okay, there we go. All right. I'm looking. I don't know if I even see any comments. I see it on Twitter. Whatever. Let's go. Let's do stuff. Let's build some stuff. Here we go. So first I want to talk about the BuidlGuidl. The BuidlGuidl is an organization that works to grow and nurture developers on Ethereum. We spend a lot of time thinking about education, curriculum, what to build, how to build it, why we're building these things. And then we teach those things back to folks. you can get started at Speedrun Ethereum. Speedrun Ethereum is kind of like our main curriculum. Let me pull that up, speedrunethereum.com. You'll go through building an NFT, building a staking app, building a vendor, building a dice game, building a DEX. But this is just the start. This is just to get you going and get you in the mode of shipping. Then you kind of want to take Scaffold-eth off the shelf and build a few apps, try to build a prediction market, try to build a stable coin, just a handful of things that already have product market fit in the space, things that you can learn a lot from, just learn by doing, and Speedrun Ethereum can help you do that. Then we have a batch program. We bring people through into our batch program. It's about like 30 people a month. It's kind of small, hands-on. We focus on teaching you about open source contributions, making a PR, things like that. And then we send you off on your way with a small grant. And so we have a small grant system you can apply for as you go through Speedrun Ethereum. Today, we'll be mostly focusing on Scaffold-eth, how you build on-chain. And we'll tinker a little bit with a little bit of AI, maybe. Maybe I'll just yell at the AI and ask it to make me a coin or something. Who knows what we'll do? That's the fun part about it. But BuidlGuidl has lots of featured builds. Since we have these toolings, we have these stacks, we have these curriculums, we're always building stuff. So if you don't see, oh no, I saw something there, let me see the comments. There we go. Oh yeah, I see some comments. GM, okay, great. It's great to hear. Yes. If you don't see the chat, big sad for the audience. I see the chat now. Drop some stuff in the chat. GM Rohan Narrow. Let's go. Okay, so apps. I'm talking about apps built by the BuidlGuidl. We have tons of just public good apps. Address Vision, Hacked Wallet Recovery, ABI Ninja, lots of stuff built with Scaffold-eth. We have cohort streams. So we're streaming to developers, up and coming high impact devs. And we do this in a way where we built our own streaming contract. We built our own streaming system and we stream to these devs. We're partnering with ecosystem heroes. We're building our own client, and you got to put quotes around it because it's just a client. It just runs Reth and Lighthouse, but it's this really nerdy looking client, the BuidlGuidl client. And it kind of gives you this, it's actually right back here on my screen if you can see it. It's this thing right here. It gives you like this really nerdy looking kind of like you're launching a rocket or something. Oh yeah, there it is. Thank you. Okay, awesome. And down here at the very bottom, there's something called the tech tree. And this is something we're still working on. But this is a great next step for you after all of this stuff. So hit Speedrun Ethereum, hit Scaffold-eth, get good at building things, and then hit this tech tree right here. We're going to have a much better version of it soon, but it's just a kind of a crazy Miro board right now. It's one of these things. I'm definitely the Charlie here, drawing all these crazy drawings, and it's just a lot of different things you can build on ETH and things you should learn that are going to help you build things. But all of that you can find at BuidlGuidl.com, BuidlGuidl.com. But we're going to move on to Scaffold-eth. We're going to focus on the just building something silly, building a little app, getting you started so you understand how you can get started and prototype and build stuff quickly. I don't see any questions in the chat, just lots of GMs. Love it. Okay, so here we go. So I'm going to start with Scaffold-eth. I'm going to start with complete scratch. So you can go to scaffoldeth.io. Let me see if I can paste that into the chat. I probably can't. Yep. I think if you just Google Scaffold-eth, you'll find it. There's a great documentation page. Of course, it's like all open source and very, very, very forkable. That's kind of the point. We also have an extension system. So if you're trying to run a Ponder indexer, or you want to make a token, or you want to run a subgraph, or my favorite extension, I wish it was highlighted here, is the on-chain kit. The on-chain kit is so good. It's got like a token selector. It's got a token swapper. It's really good. It's meant for Base. I bet you could bring in a smart contract wallet really easily. So if you're building something fun on Base, check out that on-chain kit. Okay, the on-chain kit, check out on-chain kit just individually, but also check out the on-chain kit extension for Scaffold-eth. They're both great products, great tools for building on-chain. Okay, just tons of great extensions here. We had an extension hackathon, so we had a lot of community builds. I'm just going to start from scratch, though. No extension. I probably will just make a simple ERC20 or something, so I totally could use this extension, but I think I'm just going to start from scratch. I'm going to copy this, and we're going to bring up a terminal. Let's make it real big. That's probably still not big enough, but here it is. So I'm going to do an npx create ETH at latest. So this is what you need to remember. MPX create ETH. Anytime you need to quickly prototype something, build something quick, show off a quick app, build something that talks to some other contract, put a new contract out there, MPX create ETH. And let's see, what are we going to make? I think I'm going to make, I was thinking about this. I think I want to make just like a token on like optimism. So it's not going to get traded around too much, just like a little silly token. And I think I want it to die in 24 hours. So it's like a safety thing. I don't want to have a token that like goes nuts and I get in trouble or something. So I'm gonna call this thing a 24-hour token or something like that. I don't know. We're just building, we're prototyping, we're dinking around. It's up to you to really think through the awesome heady thing to build on chain. I'm just showing you the tools and getting you started here. Notice this nice little choose your own adventure. You can choose either one of these. I kind of just randomly pick one now and then. Foundry is probably better for writing tests in Solidity. It's faster because it's written in Rust, but the hard hat guys are right on their heels. The hard hat guys are rewriting in Rust. They're running their stuff on Revum. They're thinking about Solidity and TypeScript tests. So don't count the hard hat guys out. It's great to have such a great ecosystem where we have multiple options of good tooling. Okay, so our Scaffold-eth app, our 24-hour token directory is created, right? We can jump into that directory. We're going to spin up our own little blockchain, right? That's going to run a local chain. And then we're going to deploy. So Scaffold-eth comes with like this example contract. So we're going to deploy that example contract. And then we're going to run another terminal that will do a yarn start, which is going to bring up our app. So kind of a lot of stuff here. You kind of have to launch a rocket, but you bring up your chain, you bring up your front end, and you deploy your contract. And you kind of just get in this mode where you make small changes, you deploy your contract, and you tinker with it at the front end. And let's do that right now. That's a very critical step in using Scaffold-eth and your Scaffold-eth journey. I'm going to use Cursor today since we talked about AI, but whatever code editor you want to use. If you haven't dinked around with Cursor yet, you certainly should. It's a lot of fun. Okay, let's see. Cat Truffle. Shout out to Truffle. All right. Cat, if you're still using Truffle, that's great. That's okay. That's okay. I remember back in the day, you used to have to do this command called like migrate -- reset or something like that. And it always was so off-putting to me. But now even like, I bet I will do a -- reset at some point here with Scaffold-eth. So maybe it comes full circle and the Truffle guys knew what they were talking about the whole time, but whatever. Again, another good tool. If it weren't for Truffle, so many things wouldn't have gotten built. So hearts to the Truffle team. And that dinosaur of the ecosystem. So we have a starting contract. So Scaffold-eth comes with a starting contract that's just like a nice little greeter contract that's just going to give you kind of a handful of nice little concepts built in. We've got primitives and data types, events, constructor, modifier, functions. Now, if this is all overwhelming, you probably want to go to something like Solidity by example, or just go read the Solidity docs. If you're a decent programmer, you could get in and you could learn the syntax for Solidity very quickly. Like you could pick up the syntax in a couple of sessions of tinkering around, go through this and just like learn these concepts. But once you have the concepts down, then it's time for Speedrun Ethereum. Go do Speedrun Ethereum, go build out that handful of apps. And then you're ready for this step here, which is like, okay, now I'm like open-ended tinkering. I want to build something. I want to put something on chain. That's when you get to this point. And let's fire up our front end, right? I think we have it here. Whoops, sorry. Let's go grab our front end and let's get to the tinkering part. The tinkering part is the most important part. And I'm 13 minutes into my presentation already, and we're still not tinkering. We need to be tinkering. Speed up the tinkering. Time to hello world. Here we go. So this is it. We have a debug contracts page. This is what Scaffold-eth looks like when you land on it. And this debug contracts tab is really important because it gets you in here and it lets you poke at your contract, right? Let's see, there's a greeting. We can see there's a greeting that's building unstoppable apps. There's some owner. There's some premium flag that is set to false. Okay, and then there's some greeting, right? We can say hello world. Now this is going to complain. It's going to tell me what? I don't have any gas, right? So what I need to do is just grab some money, and Scaffold-eth makes this really easy. It has like a little faucet button right up here in the top right corner, and also burner wallets, okay? And we'll get to the burner wallets in just a second when we start tinkering, but let's see what happens here. I'm just gonna hit this button and it's gonna work. There's not gonna be any pop-ups, there's not gonna be any MetaMask. I'm just gonna hit the button, we're gonna make a transaction, and I'm gonna set the greeting to hello world. Notice how fast that is, okay? So let's go look at the code real quick, specifically this right here. When we do the set greeting, there's a payable function, and if the value is greater than 0, then it's going to set some premium flag to true, okay? So let's go trigger that. Let's go make this thing, let's send in some money, right? So let's send in 0.001 ETH. Now this is gonna fail too. Watch this. Ooh, it's gonna say cannot convert this to a big int. So this interface is built for developers. This is for nerds. This is not for your end user. Your end user should not need to know about this. And when you build your front end, you'll handle all of this stuff behind the scenes. But you as the developer need to be aware of it. And you need to know that you're going from ETH to Wei. And again, if you need a run through of what the heck is ETH to Wei, you can go to Ether and Wei on Solidity by example, and it will explain it. But the TLDR is we don't have floating point math. We don't have decimals. So we do this magic thing where on the way in, we make it into a really big number. And on the way out, we divide it to make it look like a decimal. And so what you do is you need to multiply by 10 to the 18, right? There we go. There is our money that's going in. We're going to say hello world. So we're going to send this in. And look at that. Our premium flag is set to true now. And the counter is up. And this is really interesting. There's now $4 locked in the contract, right? This is really cool. So we're able to spend a little money and set, let's say, hello. Oh man, I don't know if I can spell crecimiento. Hello, crecimiento. I didn't spell it right, I bet. Oh man, my Spanish is bad too. I should know, but I did it. I said hello there. I paid some money. And now our contract is loaded up with like $11, right? So where is this money going? What happens? There is a withdraw function. And there's an owner, okay? So whoever this owner dude is able to withdraw from the system. Let's see where that's getting set real quick. I think it's right here. Yeah, okay. Let's make us the owner real quick. And what we're gonna do is we're gonna make sure that we can withdraw and someone else can't. We're just gonna test a little piece of this contract. Before we get started building too much, I wanna really show you the tinkering and the testing here. So we're gonna redeploy our contract. Let's go back to this. Okay. And we're going to get a new contract here. So that contract with $11 in it, it's still out there. We don't care about it. It's gone. You know, it's fake money anyways. Now we have this new contract and now we're the owner. Okay, great. So what I want to do is I want to say hello world and I want to put in some value, right? 0.01. I want to send some money into this contract. Okay. And I'm going to make sure there's money sitting in there. And that's important to me because what I want to do is show the withdraw pattern here. So what happens is we have this withdraw function here in our contract, and it's only owner. But I want to test that. I want to make sure, and not sure, but I want to be pretty sure that this is going to do what it's going to do without writing like an extensive test bank. I still want to be sure that this withdraw only lets the owner withdraw. And how do I test that quickly? Now, of course, I could write a big test suite in Solidity and test all the different conditions. But right here, I'm just kind of like, I'm cowboying it a little bit and I'm just testing things and I'm making sure that my assumptions are correct. So really, I just want to make sure that a bad guy can't call withdraw and take this money out. And I want to make sure a good guy, me, the owner, can withdraw it. And this is where we get into burner wallets, okay? So burner wallets, you've noticed as I'm doing like this hello world here, I'm not getting any MetaMask pop-ups. I'm not having to change my chain ID or anything garbage like that. There's no bad UX here. I hit the button and it does the thing. That's because behind the scenes, you've got a private key and local storage, which is very unsafe, but it's great for local development and local prototyping. So what we have is we have a burner wallet here. Now, if I open up an incognito window, if I go to localhost 3000, look at this, we get this green guy, okay? Let me do that again. New incognito window, go to my site, another new guy. So each time I create this new incognito window, I'm getting a completely new account. And this is super useful because I want to test this. So, okay, this guy's going to be our bad guy. And we're going to fund their wallet. And then we're going to go into the contract that has $39 in it, and we're going to try to withdraw it. Here we go. Please don't work. All right, not the owner, right? We got that error. Like, a bad guy is not able to withdraw the funds. That's what we wanted to test. So that's the sad path. Now let's go back to the happy path. Let's find out, can the good guy withdraw the funds? So he's sitting at that. We've got $39 in the contract. Okay, so it should go to 3,900 something, right? Let's see what happens. I'm going to hit withdraw. Transaction successful. Is the money's out of the contract and back into my account, okay? So this is just a little bit of tinkering. This is what I'm talking about testing, making small changes to your contract, dinking around and trying things out, testing your assumptions. Okay, so I don't know if I really want to have an owner here. I kind of don't like that. So I'm going to kind of carve some things out here, right? Now that we know this is kind of working, I'm going to say there's no owner to this contract. So it's not going to take in anything in the constructor. Oops, whoops. Whoa. Okay, whoa, man. Okay, here we go. So we'll get rid of this modifier. We'll get rid of this. We'll hit save. I don't know. We can leave most of this stuff if we wanted to, but maybe we just clean this out. Okay, yep. I'm feeling like it's a clean out. We're going for it. Okay, let's see. And what should we do here? Here, let's just do quick console log. Here's what we're going to do. We're going to show that this console log works with a fresh contract. Hello world. I'm a freshie. Okay. Oh, it's not liking that. There we go. Are we happy? Okay, let's deploy this thing. Okay, and let's see what happens. So we go here and we go yarn deploy. Now right over here is the blockchain, and looks what, oh no, something happened. I probably broke something. Artifacts. Okay, there's something in the deploy that it wants to do. I think this stuff here. Let's see if that fixes it. There's just a few little pieces of scaffolding that exist to keep everything running. There we go. Now we're good. Oh, look at it. It's reusing my contract. So if I wanted it to not reuse my contract, guess what I would have to do? A -- reset. Sometimes you got to do a -- reset just to get a fresh contract every time, right? So here's our contract. Watch what happens when I do a reset. I'm just going to keep getting a fresh contract here. New contract, right? This is 5C8. Now we have 0165, and I can just keep firing these things off, right? This is all on localhost. This is all free. This is all just me dinking around. Okay, so what we need to do here is we need to get this thing, it is deploying and it is console logging. I think that's the thing. We see hello world, I'm a freshie every time this thing deploys, right? Let's see it one more time. Hello world, I'm a freshie. Okay, so our simple contract with nothing in it is getting deployed and it's saying hello world. We're good to go. We've got a starter contract, right? And if we go back over to this debug page, it's going to be pretty lame. It's going to be empty. There's nothing here. Like the contract is here, but there's no read, no write. Okay, now let's see what the AI can do. Okay, this is when it gets really fun, because what I'm going to do, actually, I'm going to just take out the console log. I don't even want to have console logging here. I want a very fresh contract. Now with Cursor, you can just pull up this AI tab and just kind of prompt it with what you want. It's like, I would like an ERC20 that anyone can claim one for the next 24 hours, and then all token balances go to 0 in 24 hours and it becomes useless. Okay, let's see what it does. So I just send that to that and it's like jamming out, here's all the stuff you need to build and explaining all the things to me, and I probably just need to hit apply, and let's see what it did. Let's see what it built. So it brought in, let's look at this code. It brought in Open Zeppelin's ERC20. It inherited it. It's going to keep track of a start time and whether or not they have claimed, which I kind of don't want to do that. We'll change that in a little bit. It's got our name of our token. We initiate that start time when it gets deployed. Now there's a public function that anyone can call that makes sure that the claiming period is still there. And if you've already claimed, it doesn't let you claim again. And then it sends them 10. Well, what is that? Gross. Gross. I don't want that. I want to just say 1 ether. That's much nicer. And then it sets has claimed to true. I think we're going to skip that stuff. I kind of don't like that stuff, but this is really nice. And then reset balances. Okay, this is really interesting. So the balances can't just get turned into 0. It looks like it wants like someone to hit this thing. So I thought we would just extend the balance of contract or the balance of function and just return 0 if it's after some time. But it looks like the way they're doing it is they're setting it up so someone like pokes the system. And when they poke the system, it just like burns the whole supply. I don't know. This is really weird. I'm not sure. I think we want to let's see. Let's talk it out with the AI. I think we want to extend the balance of function and just start returning 0 after 24 hours instead of resetting balances. So I feel like, yeah, it's like maybe it has just a little less context than it needs about how smart contracts work. So you'll have to be kind of careful here. I would definitely recommend doing lots of good stuff like going to Speedrun Ethereum, going to Cypher and Updraft, take on some of these challenges, go do lots of reading on ethereum.org. There's context to get here that even the AI doesn't have that you'll need. Let's see if we get anything better here. Oh, get out of here. Here we go. Okay, so how has this changed? There we go. Now we have the balance of component. And if the time is after 24 hours, it's just returning 0 now. So in 24 hours, everyone's balance goes to 0 immediately. And if not, it returns the super, right? It's a hierarchy thing. It goes to the parent and asks the parent. So claim, okay. I don't like this has claimed thing either. I want people to be able to claim as many as they want. And I don't want to check it at all. I just want anyone to be able to claim it for 24 hours. And then at that 24-hour mark, I want it to be completely useless. So I don't get in trouble for anything. So let's see. How is this all looking? I mean, it looks pretty good. I think we're ready to start tinkering, right? What should we call our token? 24-hour token. Okay. T4TK. Yeah. Okay, cool. Here we go. Let's ship it, right? Let's ship it and play around with it locally and see what we think. And if we like it, we can put it out on Optimism. What do you guys think? Okay, yarn deploy reset, time to tinker around. What do we have? Do we have a token that actually works? Oh, okay, we got some deployer errors. What are we running into? Ooh. Let's see. Oh, it renamed it to your token, but I want it to just be called your contract. Like the Scaffold-eth stuff is all looking for your contract. So let's do that. Okay, there we go. We've deployed our token locally. Let's go tinker around with it and make sure it does what it needs to do. Now, we're not going to be able to test the whole 24-hour thing. So maybe we should adjust that, right? Instead of saying 24 hours, oh man, I really want to do 1 ether. It just looks cooler. Oh, it doesn't like that. Oh, I need to do that. There we go. Okay. And then, yeah, so 24 hours. We need to do something else, right? So here, we'll have a hard-coded UIT 256 public time limit. And we set it to 24 hours at first. And then we'll fill in this dog right here and this dog right here. And I think that's the only 2 places that 24 hours. Okay, so then we're just going to turn it into like 2 minutes or something, right? So just for testing, we'll do 2 minutes. So this token should be active. You should be able to claim it. You should be able to send it around just like a normal token. But in 2 minutes after deploy, everybody's balance goes to 0. a programmed rug. Here we go. Let's deploy it and tinker around with it. Nobody in the chat. Where are you guys at in the chat? Hope y'all are still following along. We're deploying a 24-hour token. Okay, let's see. I need to call claim. Yes. Okay, the total supply goes up, and I can call claim as many times as I want. I can check my balance. What is it right now? It's at 3 ETH. Okay. And now we're just waiting for the time to happen, right? Maybe a little function that lets us know like how much time is left. Because now that we're waiting 2 minutes, this is kind of some dead time here. I should have done something more. Okay, let's go dink around with a front end while we're waiting for 2 minutes. Let's make a claim button in the front end, right? So after you work on your smart contract for a while, you get it working the way you want, then you're going to move over to your front end. And we'll just kind of quickly, sorry for my ADHD jumping around here. We're going to go just start tinkering around with the front end while we're waiting for our 2 minutes to elapse so we can test that our balance eventually goes to 0 here. This guy's balance, right? I'm waiting for 2 minutes. I should have set that for 30 seconds or something like that. Okay, but we're also going to clean out our front end. We're going to start building some front end here. It's this home page right here. We're going to carve all this stuff out, and we're going to start working on some code here. Let's maybe take that stuff, hit save. How's this looking? There we go. Kind of took that stuff out here. Okay, and we're going to be, this is 24-hour token. Yep, we'll get rid of welcome to. We'll hit save. How's that looking? Oh, yeah. Oh, yeah. All right, we'll put a claim button in there in just a second. But our balance should be 0 now, right? It's been about 2 minutes. I'm triggering the faucet because when you're on localhost, there's nothing creating new blocks. So the timestamp doesn't move along. So when you're working on localhost and you need like a timing function, sometimes you have to just trigger some random transaction to get a new timestamp on chain. Okay, now let's check our balance. It should be 0, y'all. I hope it's 0. You guys think it's gonna be 0? Yes. Okay, cool. All right, so our rug token is working. It is going to break in the allotted time. And yeah, I can't. Okay, let's test sending it around real quick. Let's do a new deployment. I'm gonna yarn deploy reset. Okay, then I'm going to go claim some. Okay. Then I want to transfer those, right? We need to make sure these work. So I'm going to transfer these to atg.eth, my ENS. And I'm going to transfer just one of them. Okay. And hit send. Awesome. Okay. It looks like it's working. And if I disconnect and I connect my MetaMask, okay. And oh, wrong guy. Oh, well, let's see. Oh man, account management in. Oh man, this is why I use burner wallets. What do I need to do? I need to get in here and I need to hit this. Oh, MetaMask. You drive me nuts, MetaMask. Okay, here we go. Now let's check this dude's balance before the time runs out. Okay, it's still 1, but here in just a minute, it's going to be 0. Okay, let's go back and let's make that claim button. Let's go build our front end, right? Let's go back to this page. I want a button right here that lets me claim, and then we can deploy this thing and anybody can go claim this token. So we'll get rid of some of these things. After I cleaned that stuff up, there's some little errors here. It shows a connected address. Okay, now when you're going to make a read function, right? We need to read and write from the contract. Let's read our token balance first. So you can ask the AI to build this. You can go to the docs. You can build it yourself. I think I'm going to just go to the docs and do a copy paste. So here is the Scaffold-eth docs. There's this interacting with your smart contract section. You can grab that and you can go to read. And this is what we need right here. I just need this little chunk of code right here. And I'm going to put it right here. And by the way, we're using WAGMI and VM. So we have all of that stuff under the hood. So you can always drop down to that stuff. But then we've created our own abstraction slightly on top of that just to make it a little smoother. We handle wallet stuff and a few other things. So watch this, though. Let's make sure this comes in. Okay, we've imported that. Okay, now we're going to talk to your contract. What function should we call? Watch this. If I hit Control Space, it knows about my smart contract. It has all the artifacts from the smart contract already loaded into the front end. So I can go, well, what thing do I want? I want balance of, right? And I bet I need to pass in the the connected address that we're getting from use account from WagMe, right? That's whoever's connected. Let's go look at the front end. The connected address is whoever's connected, right? If I disconnect here and I go back to my burner wallet, it's this dude, right? Okay, let's go back to MetaMask for a second. Wow, that was weird how that connected. And let's go look at our balance and let's make sure it's 0. Let's make sure our coin is correctly rugging. Oh, whoops. It's still 1 because of that timing thing. I need to hit this one more time, trigger a transaction, which gets us a new timestamp, which is a minute later or 2 minutes later, and it goes to 0. Okay, everything is good there. Our contract is working the way we needed to. I'm kind of jumping around here. I'm going between contract and front end, just trying to go fast. Let's finish up our front end. Let's make a display here that shows how many tokens we have and then lets us claim some tokens. So we're doing a use scaffold read on your contract for the balance of the connected address. Okay. And then I'm just going to call this your balance. And then down here, we could probably just have a div that shows your balance. Ooh, that's not going to work. Let's see. Let's see. I think it's going to yell at us. Let's see. Oh, it's just empty. Ooh, wow. Okay, let's redeploy. Let's get a good contract out here. Let's set it to 24 hours. We know this is going to work. It's going to go down to, well, we're pretty sure it's going to work. We have not written an extensive test bank, and I may be missing something, but it's pretty simple. Oh, what if we do one other thing? This claim, I kind of want a little bit of like rate limiting somehow. And here's what we're going to do. Here's what we're going to do. We're going to create a mapping. And this is going to be a unit 256 to bool. And we're going to say has claimed this block or something like this. No, this, what do you think? This minute? I don't know, something that makes it so there's like a rate limiter. Okay, what I was going to do is put in the block number and have it be true once you withdraw on that block, and then no one else can. And I think on Optimism, you get a new block every time. So all that would do is just prevent someone from writing a script that just like claims a whole bunch of this stuff. But that's still not good enough. I think what I want to do is I want to have a UNT 256 public. I want to say last claimed. Okay. And I want to then, when someone claims, I want to set the last claim to whatever the block stamp is, but I want to require something. I want to require, there we go. Yes, there's some, not time limit though. We're going to have some other thing that's going to be called claim limit. Sorry, I'm making my contract more advanced. I should be shipping my app, but let's say you can only claim every 30 seconds. Okay, now it gets a little more interesting. And then we say last claim plus, is that right? I don't know. I don't know if that's right, but I know how to test it really easily, right? Okay, so we know the time, we know our balances are going to go to 0 in 24 hours, but we've also added this new mechanic where out of everybody in the world that's claiming, only one person can claim every 30 seconds. So there's definitely some collisions that are going to happen on this claim thing. But we need to test it. And I've written too much stuff here to not test it. And I know I'm over there in the front end, but we're going back to the smart contract for a second. Let's go deploy this thing and make sure this new mechanic that I just added on the fly is going to work the way we want it to. We want to make sure that, what are we going to test here? We want to make sure that this claiming collision thing works. So I will claim, yes, and that will work. And now if I claim again, it should yell at me, right? Yes, okay, you have already claimed. Oh, I don't like that message though. Let's only every 30 seconds. Or maybe like too fast, slow down. I don't know what I should say there. You should have a better message there for sure, but we're just kind of throwing it in here. Okay. And then if I claim, it's still failing, right? And if I move the time along and then hit claim, it worked. Okay. I think that's working. I'm happy with that. I'm saying it feels like about every 30 seconds I'm able to claim. I get a nice little error when I don't. Let's call it good. Let's say our contract is great. Let's now move over to our front end. Okay, again, back to our front end. So 24-hour token, we know who's connected, but the balance isn't quite right. I'm not sure what's going on here. Let's go ahead and redeploy. And let's go ahead and claim some tokens. And let's make sure we get this balance showing up correctly. So we'll go here and we'll claim. Okay, and now if we check the balance of this dude here, it's definitely set. Okay, so if we go here and it's not showing here, there's something wrong. Let's figure out what's wrong. Let's go to our page. We're getting your balance. We're reading the balance from your contract. I think what you need to do here is just like a .to string maybe. Let's see what happens. Oh yeah, that's better. There we go. And maybe even like format ether. And we'll bring that in from VM. It's like maybe we have one. I mean, that looks right. What? I don't know. You know what? The AI is fixing it for me. I'm happy. Thank you for fixing it. Does everything work here? Oh, wait, I'm redeploying my app. I don't need to redeploy the smart contract. Okay, got to go back and claim some. Okay, now back to our app. Our balance is 1. Okay, it's working. It's not centered. Let's have AI center the div. I'm so bad at centering a div. Let's go. Let's see if AI can do. Oops, that wasn't what I wanted. Hey, get out of here. Okay, go back to our page. Give me some AI. I'm going to grab a new thing and say center. This is so funny. Like if you are a builder and you've worked with front end stuff, you know that centering a div is so hilariously hard sometimes. It's so funny that like we're writing this heady smart contract, sort of this heady contract. You can really get into some really heady smart contract apps, and then you'll have to drop out to make your user interface and spend 20 minutes trying to center a div. Let's see how the AI does it. Center the div for the your balance display, please. Please. It's got to be, yeah, Flexbox. Nice. Ship it. Thank you. Ship it. Save it. Let's go. How's our app look? Hey, we centered the div on the first try. Okay, now we need a claim button. We're reading from our contract, but we need to now write to our contract. Let's ask the AI. I don't think the AI is going to get this right because there's a handful of other things have changed with Scaffold-eth quickly, and the read and write functions are a little bit different. Maybe I could even pass it in. Here's how I'm going to do this. Here's how you write to a contract with Scaffold-eth. So you do that, and then you do this. Okay, and I'm going to tell it to make a claim button that calls the claim function on the contract. Please. Now, I don't think it's going to get this right, but let's see what happens. Let's try it out. Let's see what we got. Right, okay, so it creates write contract async. It's going to write to our contract, and then we have this contract writer, write contract async. It calls claim. There are no arguments. I think it might have worked. Let's go see if it worked. Let's go do a claim and see if it works. Okay. What might be really nice is a little countdown. Like if I had more time here, a little timer that ticks down to lets you know how much time you have until you can claim next. I would like that, but I don't think I have time to add that. Let's go see. Oh man, center our claim. Center the claim button, please. Go. Thank you. Accept. Oh man, what is happening here? I'm hitting accept and it's not working. There we go. All right, now, nice. Okay, it's centered. All right, let's see if we can claim, folks. Please work. Ooh, transaction successful. We got 2 tokens. It's working. And if I hit it again, it's going to be like, blah, blah. You don't have enough time. Very nice. Very nice. Okay, so if we had more time, I would build in some mechanism here to count down, tell me how much time I have, make this more interactive. But we got to get this app out. We got to ship this thing because we have just another maybe 5 or 10 minutes left here. And I'm also very open for questions. I don't see a lot of questions in here. Maybe I'm explaining everything perfect, but maybe not. Ask your questions if you got them. It's time to ship our app, though. We sort of spent a lot of time tinkering with our smart contract, getting it to work, making this token that dies in 24 hours and lets anyone claim, but only one person every 30 seconds. We then tinkered with our front end. We used Scaffold-eth hooks and WAGME, and it shows the connected address, it shows our balance, and it even lets us hit claim and claim tokens and write to our contract. Maybe we could put a little function in here to allow people to maybe send the token around, but I'm going to assume that you can use your wallet for that. There's some stuff that you could do. This is as simple as it gets. Let's ship our rug token. I think it's about ready to go, our 24-hour token. I want to get one last look at the code before I put this out on a real network, just because there's certain things that don't need to. Yeah, it's good. It's as tested as it's going to be. Don't go buy this. This is a garbage token. This is an example. Do not buy this thing. But we're going to go deploy it. I think Optimism is a big sponsor here, so I think it'll be fun to deploy this to Optimism. And it will die in 24 hours, and anyone can claim it. But I think we're ready. So when we're doing a yarn deploy here, this is deploying to our local chain, and it's using an account that comes with the local chain. So we're going to have to make our own account. I'm going to yarn generate. And that is going to, I think it's going to ask me for a password. Ooh, there's something new here. Ooh, I've never done this before. Stick with me. Make a very simple password and hit enter. And I think what that is now an encryption key, okay? And it's going to encrypt my private key. So there's a nice private key deployer that's encrypted locally. So it's going to be very hard to leak this thing. But first of all, you should never be copying private keys around, first of all. Second of all, like even if you have a private key in plain text, that's a little scary, but you want to keep it isolated. In this case, I'm only going to put enough money in here to deploy a contract. There's no reason I should have some seed phrase with thousands of dollars that I'm copy pasting around to deploy contracts. If you're doing that, you're doing it wrong. Patrick from, I guess I say Chainlink Patrick, but it's Cypherin Patrick now. He's super strong opinion on this and having everything encrypted. So we knew we needed to do it. I think Hardhat will eventually do it, but since we're using Hardhat here instead of Foundry, there's no encryption. So Scaffold-eth built its own encryption right on top of it. It just does this EAS encryption, I think. But the Scaffold-eth team just shipped it. Shout out to them. But it looks like it's working. So what I need to do is fund this account. If I do a yarn account now, it should give me like a nice little QR code maybe. Oh, password. I've got to type in my password. Sure. There it is. Okay. So now we need to fund this account so we can deploy our contract. Hopefully we're doing okay on time. Let me know in the chat if I need to like hurry or anything. I think 10 more minutes and we got this thing. But yeah, lots of open to lots of questions too if you have any questions. Okay, so I'm going to use a burner wallet and I'm going to send some Optimism into this address. I think maybe like $5 or something. I'm pretty sure it costs like a couple pennies to put a contract out, but I'm going to be safe and just ship $5 over there. And we're ready. Okay, are you guys ready to deploy a token to mainnet? This is a really bad idea. Here we go. All right, so we're going to do a yarn, yarn deploy. And now when I just do yarn deploy, it deploys locally. It deploys to this local chain, right? We don't want to go to that chain anymore. We want to go to -- network Optimism. All right, here we go. Please work first try. Let's see what happens here. Yeah, I wonder if like bots are going to start claiming it. I really hope not. This is a valueless token that is going to be worth $0 in 24 hours. We're just playing around. This is a playful tech demonstration for developers. Okay, so we've deployed our contract to Optimism. Now if you go look at our app, it still says hard hat. What we need to do is we need to switch the configuration for Scaffold-eth. So I'm going to go to the scaffold config, which lives in the Next.js folder. And this is where you configure a bunch of little things about Scaffold-eth, but in particular, your target network. I'm going to put in optimism. Now watch this. I'm going to change one little thing and hit save. And now my entire app now is on optimism. Every single address component you see, everything is now on optimism. So if I connect my wallet, okay, it should bump me over to the Optimism network and let me claim a token. Yep, I'm about to claim a token on OP mainnet. Here we go. I think it worked. I think it's working. I think it's working. And remember this connected address here? If I click on this, it's going to take me to the Optimism Etherscan, right? So as soon as we flipped our app over to Optimism, our entire app just works on Optimism now. Okay, but we're still on localhost. And it's also saying my, oh, there it is. There's my balance. There's my balance. I feel like that was a slow load. Can I speed that up at all? Let's try again. Okay, I can't claim for like another 30 seconds, right? So we got to wait a little bit. Transaction is likely to fail. We got to wait just a little bit longer. I really should have built something into the front end to give us some feedback. Okay, so we're going to claim that in a second. We're still on localhost. The last little piece we need to do here, we've deployed everything live to Optimism. We need to deploy our app to Vercel. So the way you do that is you do yarn Vercel. And I'm going to add some extra flavor here that tells it to not do any checks and to not give me any feedback and just ship that thing without any question. So I'm going to yarn Vercel YOLO prod. Yes, I want to set that up. And I'll just say yes to that. And there we go. That's it. We've deployed our contract, and now we're shipping our app to a public URL. So within the last 50 minutes, we've kind of just made something up, made up a silly token. We tinkered with it. We added a few mechanics to it. We had that nice interface with Scaffold-eth where we could debug the contract and we could poke at things and we could try things and test our assumptions. Then we moved over to our front end and created a nice little claim UI where anyone can hit claim and pay a penny and collect this 24-hour token that will be worth $0 in 24 hours. And it's working. I'm getting notifications. I'm seeing it. Okay, and our app is shipping here. So as soon as this is done, there will be a live URL, and anyone will be able to go there and connect their wallet and claim some of this 24-hour token that will be worth $0 in 24 hours. So maybe don't, but this is an example. This is an example of you building on chain with a little bit of AI. We used a little AI, right? We use the AI to center the div and stuff like that. I'm happy with the amount of AI contribution we had to this project. It was just right. But you could get in here and do a lot more with Cursor, right? Like the timer. There's a handful of things I want to add here that would be nice. Like give me a read function here that tells me how much time is left. I'm sure the AI could bash that out in a second. And then I would go to home and say, display how much time is left. Maybe like in this claim thing, if there's time left, this thing is like disabled until there's the right time. I don't know, something like that. But I think we've got it. As soon as this thing deploys, we'll have a live app. Anybody have any last questions? Any questions from the crew? Hit me up on Twitter. I'm at Austin Griffith. I'm this guy. Go find this guy on Twitter and ask him a question. The DMs are open. Hit me up. Go to Speedrun Ethereum. Go to Scaffold-eth. Go to BuidlGuidl. Try out some of these challenges. Go build something cool. Take Scaffold-eth off the shelf. Grab one of these extensions. Make something neat on chain. Go build an ephemeral prediction market. Go build a stable coin, like I said earlier. Think of the things in that tech tree, right? Go down to this. Let's go to this tech tree real quick and look at it one last time. Go build a token, right? And then make a wallet for your token. So it's really easy for people to send around. Build a DEX, build a dice game. These are kind of all in the speed run. Any questions? Feel free to ask too. Go build, use a Chainlink price feed or an Oracle price feed to do lending possibly, or do some kind of liquidation thing, you know, build something that has this. We almost made our token liquidatable, where it was like at 24 hours someone needed to poke it to liquidate it, but then we rewrote it and it's much better now with that balance of. Get into zk, right? Zk is huge. Zk is going to be huge in the next 10 years. Get into zk, learn zero knowledge stuff, learn CIRCOM, learn how to have a zk proof settle into a smart contract and prove on chain. Build a TCR, right? Token curated registry. You probably haven't heard that in a while. Go build one. Like we used to have so many cool experiments in the Ethereum space in like 2019, like so many fun things. Bring some of those back. Yeah, front run an NFT mint. So make an NFT that, I think our app shipped. Let's see. Make an NFT that the longer it's been since it was claimed, the fancier the NFT is. And then do that on mainnet or something with a public mempool, and then front run people who are minting it. So you get the fancy one and they get the dinky one. Super fun, super fun. Okay, here we go. We are on a live URL. You can actually go to this URL. Here, let me give you a QR code. Let's go to eth.build. Let me whip up a QR code real quick for y'all. Here we go. We want a QR. We want some text. I'll paste this in. This is eth.build, by the way. If you haven't seen eth.build, it's a curriculum. It's like a little workshop where you can do things like bring in a blockchain and see what the block number is on the blockchain. Oh, looks like it's 0. Oh, there it is. Okay, so here's that QR code, though. If you would like to get some of this shitty ephemeral token, it's available here at this QR code. If you scan that, I'm going to try it. I'm going to scan it. Let's see if I can do it from my phone. If I can do this from my phone, it'll be magical. Let's see if I can claim some tokens. Okay. Oh yeah, 24-hour token. It's happening. I'm going to connect my rainbow this time. Okay. All right. I think that's about the end of it. I think we've built out most of it. Go speedrun Ethereum. Go claim some of this rug token. I mean, don't, probably. It seems like a bad idea. But hopefully this has showed you how you can build stuff on Ethereum. Let's see. All right. Yes, I'm connected. Maybe. All right. Yeah, connect. Working. All right, so I can go claim it. You guys don't need to see me claiming on my phone. It's worrying though. I have a mobile app and I can go claim the thing. It's really cool. I freaking love building stuff on chain. And a little help from AI today was nice too. Any last questions? Any closing questions? Anything out there? Anyone have any comments? Am I forgetting anything? Okay, hold on. No one's claiming. I'm gonna go claim. Connect my Rainbow wallet. Connecting in. Here we go. Connecting to my app. You're connected. Anybody out there with any last questions? Okay, yeah, please introduce the next speaker. Let me know. Kick me out of here. Thank you all. Thank you for having me. Hearts, hearts, hearts.
Austin, what an amazing experience having you with us today. Let's go.
Thank you so much. I'm claiming right now. Thank you so much.
Have
a good one.
No, thank you for your time and energy. That was wonderful. Well,
anytime. Go build stuff on chain. Hearts, hearts, hearts.
Let's go. Bye. Thank you. And well, next we will be listening to Antonio Ufano from zkSync. Antonio will be talking about, let's see, okay. Antonio will be talking about building, there it is, building Web3 apps with Web2 UX on zkSync. So Antonio, thanks for coming. Welcome. The stage is yours.
Okay, I guess we're live. Cool. I hope this works. Let me share my screen. Can someone confirm if you can see? Okay, there we are. Nice. So let me put this in slideshow. I'm going to be talking about how to build Web3 apps with Web2 UX on zkSync, thanks to zkSync SSO. Obviously, first of all, we are one of the sponsors of the hackathon. We are running a couple tracks. One of them is the best app built on zkSync. And this is a general track. You can build anything, but here are some ideas. You can build anything with AI agents that are like super popular. You can build something related to payments and checkout experiences, or anything that implements native account extraction on zkSync or Paymasters. The other track is more focused on zkSync SSO, and what we are looking is integrations in existing apps. I will be doing a demo today, so that will be very helpful for this track. Also application templates, like if you want to do a template of an application that has SSO out of the box in Next.js, React, Vue.js, whatever, that would be nice as well. Or modules for accounts that follow the ERC 7579, which is the EAP that we use for SSO. And again, the demo that I'll be doing today is about SSO, so that will be very useful. So super quick, my name is Antonio. Happy to be here. I'm a developer relations engineer at Matter Labs. Before that, I worked as a software engineer for almost 12 years in banking. So yeah, I have a lot of experience building software. And a few years ago, I quit my job. I started learning Solidity and about Ethereum, EVM, and here I am today. So yeah, that's Ufano is my Twitter profile, and zkSync Devs is the account that we have where we post updates about zkSync. Super quick, the agenda. I will talk a little bit about zkSync Era and zkSync in general, what makes zkSync Era different, how to build a zkSync from a high-level point of view, and then we'll jump into a VS Code to see a project. So what is zkSync Era? It's a general purpose layer 2 rollup that scales Ethereum with zero-knowledge tech. And basically what it means is that as a layer 2, we increase the throughput of Ethereum. So Ethereum does around 15 transactions per second. With zkSync, we can do up to 200, and while maintaining lower transaction fees. The fees on zkSync are close to a cent. We do this by moving the execution of the transactions of the layer 1 onto the layer 2. And what we do is we execute the transactions on the layer 2. We generate a proof that those transactions are valid. We send this proof to Ethereum, where we verify it. So we use Ethereum as a data availability layer, which means that we inherit the security properties of Ethereum. Just a few numbers. We launched zkSync Era on mainnet in March 2022. It was the first EVM compatible first EVM compatible rollup to use zero knowledge proofs. And since then, we have spent more than $7 million in security audits, because ZK at the time and even today is a very, very new technology applied to blockchains, to scale blockchains. So security is our main priority, and we are spending a lot of money in audits and bug bounties. Even today, I think we closed the latest bug bounty, which was like $500,000, something like that. Since then, it's the most used ZK rollup, with more than 430 million transactions on mainnet and more than 2.5 million accounts, different accounts. We also have more than 2 million smart contracts deployed on mainnet, and the transaction fees, as I mentioned before, are close to a cent. And if you heard about zkSync before, there's been a lot of changes lately in what is zkSync. So the first base version of zkSync was launched, I think it was in 2021, and is what today we call zkSync Lite. And it was a protocol that uses zero-knowledge proofs, but it was limited to doing token swaps and payments, and then later NFTs. So the only thing that you could do with zkSync originally was just these actions. Then, as I mentioned, we deployed zkSync Era, which is a general purpose blockchain, so you can build any type of smart contracts that you can think of. And it was at the time the first, or even today, the first EVM compatible layer 2 rollup that uses zero knowledge proofs. And later this year, what we did was we upgraded the bridge contracts on Ethereum to allow them to support multiple rollups, which means that we transform zkSync from a single rollup into a network, into what we call the elastic network, which is a cluster of interconnected zk chains built with the same or similar properties as zkSync Era, and all of them will be interconnected, sharing liquidity and users. And all these zk chains are built using the zk stack. So if you're a developer, if you're building for this hackathon, your entry point to building on zkSync is Era, just to clarify it. So what makes zkSync Era different? Because at the time we launched it, it was the first zk rollup that was EVM compatible. But since then, we've seen many zk rollups launching. But there are a few things that still makes zkSync Era special. The first one, it's EVM compatible. So that means that you can write your smart contracts with Solidity and Viper, and what you use is a specific compiler to compile those contracts into the bytecode that is executed by the Era virtual machine. Second one is performance. Is one of the most, if not the most, performant layer 2 rollup out there. We did close to 200 transactions per second on mainnet while maintaining very low transaction fees. And we are able to do this because we use state diffs. State diffs is how you post, or how the rollup sends data to Ethereum. And normally optimistic rollups and other zk rollups, what they do is they send the information of all the transactions that happen in the layer 2 plus the validity proof to the layer 1. And that means that you have to send a lot of data from the layer 2 to the layer 1. And obviously, the more data you send to Ethereum, the more it's going to be more expensive. What zkSync does instead is we take the original state of the blockchain. Let's say I have 1 ETH and you have 2 ETHs or something like that. And then we have a batch of transactions where contracts are deployed, transfers happen. So what we do is, instead of sending all the information of all these transactions happening, we send the new state that happens at the end of the batch. So it will be, okay, now I have 1.2.5 ETH, and there is this new contract that was deployed, etc. And the only thing that we send is the difference in the state. This means that we are sending less data to Ethereum, which means state transitions cheaper. And this is very good for applications that updates the same storage slot frequently, because you are only charged once. You can, for example, an Oracle that updates a price feed 100 times, they will only pay once. Finally, zkSync implements account extraction natively with smart accounts and paymasters integrated at the protocol level. I'm gonna explain a little bit more about this now. So as you know, account abstraction was like the hot topic in 2023 when EAP 4337 was launched, and 2024 was supposed to be the year when smart accounts will take over, but from my point of view, it didn't happen. Everyone is still using their MetaMask account or any other EOA account. We have to sign transaction. We have to pay gas fees. So yeah, right now, account abstraction is still what we have on mainnet is EAP 4337, and there are a bunch of other EAPs that are being discussed, but none of them is on mainnet. So we're still waiting for more updates to make the experience better in general. On zkSync, on the other hand, we knew that we wanted to have account abstraction integrated at the protocol level, and we were building a protocol from scratch. So we didn't have any limitations on how to do it, and we did it slightly different than EAP 4337 and other EAPs out there. So as I mentioned before, account abstraction on zkSync is implemented at the protocol level, and it's a simplified solution compared to EAP 4337, which makes life easier for both users and developers and even people maintaining infrastructure like running nodes. Smart accounts and paymasters are first-class citizens on zkSync. This means that all accounts, even externally owned accounts like your MetaMask, behave like smart contract accounts, and all accounts support paymasters. Paymasters are these smart contracts that enable gasless transactions or allows users to pay fees with ERC20 tokens like USDC. There is a single mempool and a single transaction flow, and I will show the differences between EAP 4337 and this implementation that we have. So all transactions from EOAs or for smart contract accounts, they go to the same mempool, and these transactions are processed by our bootloader, which is our version of the bundler, and our operator. And basically, this is how it looks like. So EAP 4337, in case of you are not aware, I'm sorry the letters are like a little small, but there is a lot of pieces in it. What it does is it introduces a new transaction flow. So on the top, you have the transaction flow for transactions that are originated from an externally owned account. And in the bottom, you have the transaction flow for transactions that are initiated by smart contract accounts, what they call user operations. So totally different. There is a different mempool, one for EOAs, one for smart contract accounts, and then different types of nodes. You need a bundler, and then the entry point contract. On zkSync, this is way simpler. This is how it looks like. You have both externally owned accounts and smart contract accounts sending transactions to a unified mempool. And then we have the operator just picking transactions from this mempool, creating bundles, and then sending them to our bootloader system contract that basically validates them and executes them. And this looks like it's totally different, but as I mentioned before, zkSync is EVM compatible, so that means that you can use your tools, you can use Solidity, and everything from a developer point of view. You don't have to worry about it. It just works. So getting into a little bit more details. Okay, how do you build on zkSync? First, you can use any framework that you're familiar with, like Remix, Hardhat, or Foundry. In most cases, with additional plugins that are pretty easy to install. In Hardhat, we have the Hardhat zkSync plugin. You just install it in your project, import it in your config file, and you're good to go. There are obviously advanced settings that you can configure, but defaults work out of the box. You just need to import it, and it works. And with Foundry, we have our own version of Foundry right now called Foundry zkSync, which it works exactly as Foundry. It just adds support for our compilers. As I mentioned, you can write smart contracts with Solidity or Viper, recommended are 0.8 or 0.343 or newer. And this is the main difference. You compile your contracts with the zkSync compilers, which are zkSolk for Solidity or zkViper for Viper. And this is when the plugins comes in. You don't have to worry a lot about it. You just use our plugins or Foundry zkSync, and you can do npm hardhat compile, and it will detect that you are compiling for zkSync and use our compiler instead of the Solidity compiler, for example. And with Foundry, you can do Foundry build -- zkSync, and it will use the zkSync compiler as well. When it comes to front end, again, everything works out of the box. You can use ethers, you can use VM, you can use WAGMI, Wallet Connect, and there is a special version of ethers that has zkSync specific methods mostly for everything related to native account abstraction. So if you want to use our paymasters, or if you want to use helpers for smart contract accounts, you can use zkSync ethers, which is an extension of ethers version 6. Same APIs, etc. It's just additional methods. You also have additional SDKs for writing of scripts or any other programs that you need in JavaScript, Python, Go, and Java as well. I forgot to mention there. And that's basically it. So the experience from a high-level point of view is pretty similar. You use Remix, Hardhat, Foundry, write your contracts with Solidity. You just compile them with our compilers. And then from a front-end point of view, you can use ethers, VM, WAGMI, and everything just works. Obviously, there is a lot of things that you need apart from these tools. So from an ecosystem point of view, everything is already there. You can use Alchemy, QuickNode, ChainStack, and many other node providers if you want. You have all the APIs from Alchemy for the NFT API, the token API. All of them are available on zkSync Era. You have the graph if you're using subgraphs. You have, let's see what else. We have ThirdWeb that also have a lot of APIs, SDKs, template smart contracts, CLIs. All of them fully support zkSync. You have Chainlink for price feeds. You have Layer 0 for sending or creating these tokens between networks and sending messages between networks. You have Gelato and Pith also as oracles, Dune for analytics. Anything you can think of is available on zkSync. So there are no limitations. And also, we just released the roadmap for 2025. That's a QR code in case you want to scan it and read it later. And I want to mention just 3 things because I didn't have time to bring all the details from the roadmap. But the first one is zkSync SSO, which is a modular smart contract library that allows developers to implement smart accounts that use passkeys and sessions. Passkeys is using your biometrics to sign transactions, which is pretty cool. We will see a demo in a minute. There is a demo here, but we're going to build another one, so that's okay. We're going to have EVM equivalence next year. So right now, we are EVM compatible, but not equivalent, which means that you have to use the zkSync compilers. In the future, thanks to Bujum OS, we will be able to execute not just EraVM bytecode, but also EVM bytecode. So there will be no need for custom compilers or plugins for tools. And I mentioned super quick a little bit about the Elastic Network. So next year we will see interop between zk chains. So it will be super easy you are in a network like zkSync Era, and you will be able to call a contract that is deployed on another network from the build with ZK stack. So yeah, that's coming next year. As I said, there are more details in this QR code, and I will also have it at the end. And obviously SSO, if we're doing a demo, is because it's available today. It's still under development, but it's available to test, to play with it today. So yeah, 20 minutes, half of the time, just to give you this super quick introduction. And now we are ready to jump into the code. This QR code has a link to the repo in case someone wants to fork it and go through it with me. But if not, yeah, we can. I'll share the repo as well later on. So let me open my code editor. Okay, what we're going to build, or what I have built, is this application. It's called ZK Pulse. Let me zoom in a little bit, maybe a little less. And it's pretty simple. It's an app where you can connect your wallet as usual, and then you can create these polls. Let me connect my MetaMask, so I will show you. And in these polls, you can vote. These polls, they just only have 2 options, and then you can click here to vote. And there are, obviously, each poll has a deadline. So these ones ended already with some votes, and these ones are still open, they are active. And you can see we have the total votes, when it ends, and who created this one. I'm not sure if I'm able to vote in this one. Let's try. Which video game do I prefer? This one. And when you click on vote, you have to confirm your transaction. Okay, so that's the typical Web3 application that everyone is kind of used to use with a typical UX. Let me guide you to how I build this, and then we're going to see a new version of this application that uses zkSync SSO and how it transforms this from a UX point of view. So the repo that I shared has 2 main folders. One is contracts, and the other one is the web app, which is the front end. And in contracts, the only one that we have is this poll contract. And I'm going to make this slightly bigger. And let's get rid of this. Okay, so pretty straightforward contract. What we have is a struct that defines our polls, and we have like the owner, and then the title, what is the option 1, the option 2, the number of votes for the option 1, the number of votes for the option 2, a deadline, and then a mapping where we store the votes. When someone votes, we save the address and we put it to true. And this other struct is what we use to print the polls in the main page, so we don't need all the info. So we have this with slightly less information about it. And then there are a few events that we have, but mainly the main methods are this create poll, which receives a string with the title, another one with the option 1, another one with the option 2, and then the deadline. And we have some validations here with a require, like it cannot be empty, none of the fields can be empty. And what we do is we increase this ID, because we are also having the ID for each poll, and then we assign all the information that we receive, and the owner is the wallet that sent the transaction. The deadline is the block timestamp plus the duration that we send, and then we save both the ID and the new poll. Then the vote function, it receives the poll ID and the option that we are voting for. It should be 1 or 2. We have a require here. And then what we do is we find the poll by the ID. We check if the user has voted or not. and then we increase the number of votes. There are a few other methods like getPoll, which returns all the details. So when we go to the poll page, to the specific poll page, we get all the details like the number of votes, etc. And get all poll IDs, get vote status. Some of these we're not even using. And get all polls is the one that we use in the main page to print all the information of the polls, the polls that are created in the app. So that's the contract, and the contract is I build it with Foundry, and I deploy it to our testnet, and it's deployed here. And as you can see, it's verified, and this is the same code that I mentioned earlier. It's available here. Cool. Going back to the editor, let's see the web. So I built this front end using WACME, which is this library from the Paradigm team, or it's backed by Paradigm and also by zkSync. But it's very cool because it gives you different templates. You can use it with React, you can use it with Vue.js, and you just run npm create WACME, and it scaffolds a project with already all you need to do to connect to your wallet and a basic landing page with the button to connect. So I'm not gonna get into a lot of details about the styles of the front end, etc. But on the pages we have the index, where we print all the information of the polls. So we print all the polls. We have the create page to create new polls, and then we have the account page. So the account page is, when we click here, we can see the details of the connected account. We can see that this one is a regular externally owned account. This is my address. This is the chain ID, which is 300, our testnet. And this is the balance, which is 5.2 test ETH. If we go back to the main page, when if we want to create a new poll, we have this form, and which we can fill with the title, first option, second option, and the duration. And the other one that I was mentioning was this is the poll page where we can vote. So these are these pages here, and this one is the one with the details where we can vote. All the logic to connect our wallet or to interact with the contract is in two files that I will focus on. The first one is this one, wacme.ts, and this one has the following. First, we have the blockchains that we want this application to connect to, and then we have the connectors from WACME. And the ones that I'm using, or the one that I'm using, is just the injected connector, which basically detects any wallet that you have installed in your browser. What we do is create a config file for WACME where we pass the blockchains and the connectors that we want to use. And as I mentioned, this is created by default with WACME. It just comes with a few different wallets and maybe a different networks, but you just have to change the network and the connectors that you want to use. And that's basically it. This is the connection. This takes care of connecting to your wallet. Now, to interact with the contract, what I have is this file here called use poll contract. Here what I have is, if you are build Web3 apps, you normally need the address of the contract deployed on the testnet, and the ABI, which is a huge object with the definitions of all the methods and the inputs and outputs that it has. So I just have it compressed here. What we have here is this use poll contract method that we are exporting, and this one has inside has different methods to call the different functions of the contract. So create pool is a method that receives the same parameters, the title, the option 2, and the deadline. It receives these fields from the front end, from the web, and then we call this write contract method, which is from WAGMI as well. And this write contract receives the config that we saw before in the wagmi.ts file, and then the address of the contract that we want to call, the ABI, the name of the function that we want. In this case, to create pool, we use create pool, and the arguments, which are in the same order as they are defined in the smart contract: the title, the option 1, option 2, and the duration in minutes. This write contract call gives us the transaction hash, and then what we can do is use this method, wait for transaction received, pass the transaction hash, and we will get the receipt once the transaction is included in a block. And then we can just check if the status is reverted, we throw an error. If not, we just return the receipt. This is to create a new poll, but I also have methods here. Get all polls. This is the one that I use to print all the polls in the main page. And this one, instead of using write contract, uses read contract. For this, again, we just pass the contract address, the ABI, and in this case, we are calling the get all polls method from the contract. The get poll method is to print all the details of the poll in the specific poll page. And again, read contract, we pass the contract address, the ABI, and then we pass the ID of the poll that we want to see the details. And finally, the vote method, which we use to vote in a poll. Again, for this one, as we are writing to the contract, we use write contract instead, and we pass the config, and the same, the address, the ABI, we say that we're calling the vote, and we are passing, again, the same parameters as in the contract, which are the poll ID and the option that we are calling. And again, we are just checking the transaction receipt or waiting for the transaction to be added to a block. This is it. So as I showed you before, this works like a typical Web3 application. You connect your wallet, and then you have to, if you want to vote or create a new transaction, you have to sign your transactions, etc. So this is when zkSync SSO comes in. And with zkSync SSO, what we want is simplify all this process. What happens if your users don't have an account? What happens if your users don't have ETH in their accounts to actually send the transactions? So yeah, we want to simplify that. And for that, we have created zkSync SSO, and this is how to use it. So I have a separate branch for the integration of zkSync SSO. So I'm going to check out that branch. It's called BuidlSSO. And let's see the differences, or what do we need to do to implement SSO. So first, SSO is integrated only in the front end, so there's no changes that we need to do in the smart contract. Obviously, as this is integrated in the front end, what I need to do is install our package, which is zkSync SSO, and currently this is the latest version. Obviously, this is still under development and it will change. Just install the latest version available and you will be good to go. Now, in our WAGMI config file, we just need to add a few lines. The first one is importing the zkSync SSO connector and this call policy method. The zkSync SSO connector is similar to the connectors that WAGMI provides by default, but we can extend it with other options like sessions. So to create it, we just call the method and then we pass an object. We can pass this metadata object with the name of our application, which is in this case zkPolls, and then an icon. We will see this in action in a minute. And then we have sessions. Sessions allow us to just not ask users to sign every single transaction. And what we can do with session is we can be very granular and on what these sessions are allowed to do. So in this one, for example, what we're doing is we are allowing this session to interact, the session that will be created to interact with this contract address and the vote method. And then with this contract address, which is the same, and the create poll method. These are the only methods that will be allowed by this session. From in the use poll contract, there's not a lot of things that we need to change. Everything works out of the box. The only thing that I've added is that I have deployed a paymaster. So as I mentioned earlier, paymasters are one of the cool things that we have, or one of the cool things about account extraction, which is natively implemented on zkSync. So what I did is I created this paymaster that pays the gas fees on behalf of the users that are using this contract here. And the only thing that we have to change when it comes to our methods to create polls or write or vote is adding this paymaster address here in the write contract method and this paymaster input, which is just an empty bytes that we're passing here. And I have these additional fields in the create poll method and also in the vote method here there. That's all I need to do to implement zkSync SSO. And to show you how it works, I have the app deployed to this URL, which is also available for you guys to test in this QR code. It would be awesome if you test it. And the cool thing about this is that you can test it with your phone. You don't need to have your wallet in your phone, or you can test it in your browser in a private window with no extensions, nothing needed. And it will work just like a Web 2 application. So let me show you how it is. So this is my normal browser where I have my MetaMask, etc. What I will do is I will open a private window and open the domain. And here I have, let's disconnect because I have it from before. Here, I don't have MetaMask, I don't have any wallet. So if I do, now this dropdown shows me the zkSync connector. I click here, and then I can sign up. If I sign up, I get a pop-up that says, okay, this will create a session to act on your behalf. It will expire tomorrow at this time, so we'll give 24 hours. And then here are more details. It will have a spending limit of 0.001. This is a default value that can be changed as well. And then the core policies are what I define in the walk me config file. Like it can call this smart contract and this smart contract with this function and this function, which are the create poll and vote. If I click on connect, it will ask me for my fingerprint. I'm on a Mac. If you are on your phone, it will ask you for your fingerprint as well, or your Face ID, depending on the phone that you're using. Just like that, as I said before, I had no wallet extension installed here. It will deploy a smart contract account behind the scenes, and I don't have to worry about anything else. If I come here to the account page, I can see that this account is a smart contract account. If I click here, I can see it in the Explorer, and there are no transactions, and you can see that it was created by this contract on this transaction that happened exactly now. Okay, so I have an account. It was created by me by the app, and it has no ETH. So in theory, I should not be able to use this application because normally you have to pay transaction fees. But as I have a paymaster, if I come here, what is your favorite football team? Boca or River? I don't know. Let's just put here. it worked. There's a new vote here, and now it's 50-50. If I go back to another poll, let's see, what's the best stack for building app chains? I'm sorry, ZK stack. There is another vote. And if I go again to my account, now you see that there are transactions happening. All of this is happening completely transparent for the user. And yeah, integration is extremely simple. You just need to install SSO, add it to the WARMI file, and that's basically it. As an example, I have in the repo that I was sharing, and then I have a QR code at the end. I have this pull request in the repo that shows you the files that are needed to change to implement SSO in the app. So this is the app. Again, this is the QR code to test it. And yeah, I'm going to wrap up at the end, but I'll show you again the QR codes at the end. So main takeaways: zkSync Era is a layer 2 rollup, scales Ethereum. We use zero-knowledge proofs. It was the first ZK EVM on mainnet. We have account abstraction implemented at the protocol level. If you're a dev, you can use the same toolkits and pretty similar ecosystem dev tools. We have native account abstraction and SSO, which is a game changer for user experience. And we have a lot of updates for Q1 and Q2 2025. You have the roadmap there. How can I set up my auth server in order to provide it to my SSO connector? So currently we give the auth server, it's available on Era testnet. You don't have to worry about it. But if you, for whatever reason you want to run your own auth server, you just have to go to the zkSync SSO repo, and you will find all the details there. They have all the pieces of SSO are available. SSO is open source, so you have the accounts, you have the auth server, etc., and there are instructions to deploy it and run it on your own if you want. But as I say, currently everything is set up for you. If you are using it on the zkSync Era testnet, you don't have to worry about it. Next steps, some links to our docs. zkSync CLI, which I haven't mentioned, is our CLI tool to scaffold new projects. So you can do zkSync CLI create, and it will create a new project for you. It can be a hard hat project. It can be a front-end project. We have a lot of templates, so it's pretty good. zkSync SSO, we have the docs in our docs, so it's available there. We have the bridge in case you want to use zkSync live on mainnet, and the Twitter handle where we post a lot of updates about zkSync. It's zkSync devs. Finally, these are the main QRs that I want you guys to check out. The polls demo application. Just go ahead, use it in your phones. It's free. You don't have to install anything. We have a paymaster with plenty of ETH to use. It's on testnet or whatever. Yeah, test it out, create new polls. Let's see what people think about who is the best team, if it's Walkout River, or you can create any other poll, whatever you want. And if you're interested in what we're going to see next year, check out the roadmap for 2025 that we just published today. And final reminder, again, we have the bounties. For the hackathon, we have 8K in bounties, and we're looking for just a general build anything on zkSync, some ideas, AI agents that are super cool, super popular today, anything for payments, or any implementation of native account abstraction and paymasters. And then with SSO, you have the demo that I just showed. You can build application templates, you can integrate it into existing apps, or you can create modules for us. Right now we have sessions, paymasters, spending limits, but anything you can think of, if you want to create it, that would be awesome. And that's it. That was me. I'll leave these QR codes here for a minute, but yeah, I just did it perfectly on time. And obviously, any other questions, happy to answer them here, or you can ping me on Twitter.
Antonio, thank you for being here, and thank you for your time, for sharing your knowledge. Everything was very clear, and I'm sure it will be very valuable for all the hackers focused on this track. So thank you.
Awesome. Thank you for having me. And yeah, que tengan buen día y happy hacking.
Gracias. Muchas gracias.
Hasta luego. Gracias.
Bye. Well, and next we will be hearing from Federico Sarkis. Federico will be talking about Superchain, what it is and what it needs. But we're having this talk at 2 p.m. So stay tuned, and we're back in 15 minutes. Well, see you in a few minutes. Hello, hello, welcome back. We are here with Federico Sarkis from Mode. Federico is DevRel at Mode, and we will be learning about Superchain, what it is, and what it needs. Friendly reminder, if anyone in the audience has questions, feel free to send it through our Telegram, and we will make sure to address them. So welcome, Federico. Welcome, Jesse. Thank you for being here, and the stage is all yours.
Hey everyone, how are we doing? Thank you for that intro. So super excited to get started today. It's gonna be a pretty informal presentation, mainly because I wanted to give you, along with Jesse, here, there we go, we have Jesse. Dude, we're looking like the same. We're like headset,
Twinsies,
like t-shirt.
twinsies. We
Twinsies, I love
we
it.
planned this. We planned
This was
this.
planned. This was planned. This was planned. The idea is that you confuse us. You don't know who's who. We're both part of the Superchain, part of Optimism. So that is kind of the objective here. Hey everyone, my name is Fede, or Crypto Fede on Chain. You must know me. I have a Funko Pop of mine here. Look, a friend of mine gifted it to me. This is my off-chain version. I have my Rick one for the on-chain stuff. And today we are gonna talk to you about Superchain, what it is, what it needs, what is the Superchain, how can you contribute to the Superchain. We're gonna talk about the bounties that Optimism has set for the hackathon, and a little bit like a few ideas, a few different focuses, and if you would like to continue your ideas, if you would like to get funding, if you would like to get technical support from really advanced people, that's what we're going to cover today. We discussed the idea with Jesse of showing you something more technical, more specific about the superchain, but the ecosystem is so broad, so big, and it focuses in so many different areas that we thought it was better to give you a map of what's happening around Optimism. So yeah, I'm Fed, as I said, I'm head of DevRel at Mode. I do developer relations at Mode. We're a layer 2, focused on DeFi and AI agents. And then Jesse, yeah, present yourself, man. Oh, you're muted.
Oh,
there we
can
go.
you hear me now? Check,
yes.
check, 1, 2. All right, beautiful. Yeah, so I'm Jesse. I've been around the Optimism ecosystem for a while. I actually got pulled into the Optimism ecosystem through an early stage NFT community that was launching on Optimism. But then from there, I kind of did a podcast with another community member that was really excited and was interviewing early stage projects building on Optimism. That was kind of before the whole Superchain vision. And then, yeah, from there, I got nerd sniped, if you will, into the Optimism Foundation, where as a community manager or contribution manager, whatever you want to call it, and then got involved in governance as a delegate, and most recently as a grant reviewer for Optimism in our past season of governance.
Epic, epic. I love it. So I guess I can share my screen in a bit, but first of all, I would love to give a definition of the superchain, Optimism, and how the whole thing plays out. If you don't know, the superchain is a concept. This is what I like saying. It's kind of a reality in the community side, but not in the tech side yet. The superchain is this concept of a bunch of different layer 2s deployed that are interconnected, which have easy bridging between each other. They have shared governance, and it's this ecosystem of interconnected chains with really good user experience for anything that you use. Why or how can you do that? Well, you must know that there's a bounty and a track for the OP stack development. So the OP stack is an open source technology repository. It's a bunch of code that lets you run your own layer 2 really easily. So You could even go now to the Optimism documentation, run a few scripts, and you would be running your own layer 2. And even easier, if you go to places like Conduit, with a few clicks, you can deploy your own layer 2 or even a layer 3 using the OP stack, right? That is the OP stack. Mode, for example, is running the OP stack. The same that you would run in your home, Mode is running the same stuff. Of course, we have security measures with the private keys that deployed or the contracts. Of course, we have a scaling solution so that we can get millions of users in, and the sequencer will process all those transactions and traffic. But essentially, we're all using the same OP stack. The good thing about having a bunch of chains deploying the OP stack and running it like Base, like Mode, like OP mainnet, right? OP mainnet is at the same level of abstraction than Mode and Base, is that they are all using the same code. So if you modify some little things in the OP stack and you add a few contracts, you can enable interoperability, right? What is interoperability? It's this concept of integration and communication between chains, right? So if everyone's running the OP stack, they are all getting their messages in the layer 2 and settled in the layer 1 in the same way. They all kind of speak the same language. It's just that they are not communicating with each other. It's like having a bunch of people that speak English, but they can only speak to themselves. They cannot speak between each other, right? Once you enable those channels and they can talk to each other, they already know the same language. So it's kind of easier to intercommunicate these chains. That's kind of the vision of the superchain. It sounds futuristic, but it's going to be earlier than we think. Interop already has a few tooling called SuperSim, and the DevNet is here. And they're planning on mainnet for next year, I think Q2 or something like that. So it's coming. Now, this is like the first profile that I would like to mention to you guys. And we're going to talk with Jesse about the different paths that you can take in the superchain. That is why please ask us questions, like drop them in the chat if you have any. Even, hey, I didn't understand what the superchain is, or I'm a data scientist guy. I want to do data on the superchain. What can I do? We can answer those questions, right? So the first thing I'm going to tell you is, if you're a crazy developer that loves open source, that loves low-level transaction handling and complex complex cross-chain messaging and stuff like that, one of the greatest things that you could do is go check out the OP stack and the whole interoperability documentation and see where you can help. There's no tooling, barely no tooling. This is all new and it's growing. So if you want to be part of that movement, I would totally recommend you go there and participate. And what happens if you participate in the open source repositories and Optimism, Jesse? There's a few opportunities sometimes for developers that build on the superchain, right? Do you want to mention about some funding opportunities on Retro PGF and what it is and who it helps as well?
Yeah, of course. Excellent prompt. So you guys are, it's like, many hackathon developers, right? You guys are probably early stage, trying to build a project. And so it's like one of the most important things is it's like if you guys build a project, you'll need some sort of future funding source or to monetize. And so Optimism has kind of two different funding sources, we'll say. I'll call the first one upfront funding. And these are say foundation grants or like governance grants that you can apply to get to your project upfront funding. And then the second piece of funding that we have is something called retro funding or retroactive public goods funding. And so the difference between that and the upfront funding is that retro is exactly what it says, retroactive funding. So you build a project and you have some on-chain metrics, people are using it, there's some usage, you've had some impact, right? You can apply to retro funding to get funding for the impact that you've already had. And so kind of two different routes there to go. And this is both of these funding mechanisms are kind of under one umbrella, we'll say, with one goal called an intent. And so for this next kind of season, we'll call it, of funding, the intent is that we have chains moving, I think, 250 million dollars in liquidity between these chains per month, and so that kind of goes to the interoperability, or speaks kind of the interoperability goal as well.
I got one question for you, Jesse. Should I do stuff expecting to get retro funding?
Excellent question. Absolutely not. Retro funding is never guaranteed. Also, I will share a doc in the Telegram channel as well. It gives you kind of an overview of the grants that I talked about. And so the upfront funding and then the retro funding, and then you can kind of read more about what might qualify for retro funding or upfront funding in the future.
Exactly. So never do things expecting to get an airdrop, a retro funding, and whatever it is in Web3. Just do what's aligned with you. If you want to work on open source and help with the tooling, do that. It's great for a resume if you're looking for a job. Which, if you help in open source repositories, and especially in Optimism, it's a great way to get involved. There is a big community, but there's not a lot of people working on those things. For example, in SuperSim. SuperSim is a tool that you can run locally that lets you simulate interop. So if you want to give it a try, you can check SuperSim and run it, and you can have like a simulated interop in your local environment, so you can start testing. I only know of one developer and team that's building a project with interop already, so he's getting ahead of time, which is great. So if you want to work on something really new and that's not even being built, that's not even built yet, interop and the OP stack is a great way thing to get in. I want to now jump to, I know we have Superchain, AI agents as part of the ideas, gaming as well, identity use cases, and I'm going to give you the cheat code for hackathons, right? Why is this not a technical workshop? Because I trust you all, I trust our audience, and I think you guys can solve the technical part. Optimism has a bunch of documentation. There's a lot of tutorials around, and you have us, the mentors, to help you guide through the tooling and whatever problem you have to solve. What we want to see the most, and usually what judges want to see the most, is cool use cases. We want to see you use your brain to solve these complexities that we see around in Web3 and build small proof of concepts that you have an idea for a product that can grow, that can get users, and that can solve people's problems. When I say people's problems, it doesn't have to be like world hunger. You don't have to solve like the most complex problem ever. Even if you show me that you can improve the user experience in some type of DeFi flow, if you show us that you can do a little game that's fun on Telegram, everything, and it brings transaction to the Superchain, people like it, and it is a way for them to engage with each other and create community. If you tell me you can deploy an AI agent that helps you invest in some basic strategies, that would help people do DeFi in an easier way and lower the entry barriers for people that can get onboarded onto DeFi. All of these little things that may seem like small projects or small ideas can solve a very something that bothers us a lot, something that you repeat every day and you have to keep monitoring DeFi positions, for example. So try to think about a product, a problem, and a solution. Try to build an MVP and reduce the scope as much as you can. And if you have a nice user flow done by the end of the hackathon, you're going to have a much higher chance of winning one of these prizes, because it tells us that you use your brain, your creativity, your different backgrounds to get the problems that Jesse and I know now and that we cannot solve. we don't have the ideas to solve them. We don't have the time. We don't have the tooling. We don't have the talent, etc. So even if you think you don't have the talent, even if you think you are not good enough with code, you always will have a different point of view than the people that are involved in all of this. So keep that in mind. Be creative. Feel free to reach out to mentors and brainstorm your ideas with them and be like, hey, I have this idea. What do you think? What can I add? What should I take? What is important? What's not? We didn't want to give you just a ton of like ideas to build, because I want you to be focusing on solving the problems. What are the problems right now? For example, interop is not here, and it's going to be really hard to onboard a lot of developers. It's needed more tooling for interop. So if you understand interop, if you understand how the super ERC20 standard is going to be like, and how the experience is going to be like, and you can build tooling around that to support the interop, that is a huge thing. You know, you're solving a problem that's not even here, but Optimism really wants to solve. Other stuff is, as I mentioned, growth games. If you can build games that people really want to play, that do on-chain stuff, that are cool, minting some NFTs, a dumb game on Telegram that does whatever with AI agents, without AI agents, games for Discord, stuff like that. That is fun. That is nice. That creates culture. That creates community. That creates growth, right? I don't know, Jesse. What you think? What do you want to see built?
No,
What is?
well, I think you hit the nail on the head as well a little bit earlier. So it's like with interoperability in the super chain and all these chains talking to each other, it doesn't matter if we don't have cool apps that people actually want to use. And so I think that like the craziest ideas that you guys can come up with, don't be afraid to share them. And Fede and I are also in the Telegram, so feel free to reach out to us anytime. I'll definitely be monitoring the chat if anybody wants to talk or just BS about an idea.
Yeah, I'm looking right now at the prices. So usually, I know you hackers, you're always here to ask about how do I win this prize? How do I target that? How do I do this, right? So just checking at the prices, we're asking for Superchain AI, gaming, and beyond. Why? We want apps that people want to use, right? We want to see cool, fun things. That is what we want to see, innovation. So for AI agents, my recommendation is that you use ELIZA. It's a very well-known repo now from AI16Z. If you have no idea what I'm talking about, please ask us in the Telegram. If not, maybe we can send the links in the comments. But the important thing is we have 3 places for this category of Superchain AI, gaming, and beyond. What does beyond mean? Any fun activities. Just full blast. If you want to create a Telegram mini app, that is a fun thing. Just know that Telegram mini apps are web apps, so it's really easy to build. Just a little tip: if you haven't tried with Telegram web apps, it's really easy to get them going. I don't know. I think so much in the deep side. Yeah, go.
Yeah, one understated thing that I don't think many people realize is that Farcaster is actually on Optimism mainnet, and Farcaster has so much going on, right? So it's like you can use Farcaster for frames, and so it's like if you pop on Farcaster, well, Warpcast is the client, but if you pop on there, right, like you'll see these frames. People are doing really innovative stuff with them. The last one I saw was, you can say log into Farcaster, Warpcast, and then connect your wallet and mint an NFT from a frame, or do literally whatever you want. So there's some crazy ideas out there that I'm sure that could be integrated with Farcaster and their frames as well. So I would definitely check that out. I'm thinking kind of higher level as well, like problems, like personal problems that I would like to solve. So it's like, to me, the vision of the super chain is the benefit from the user experience side. So say you have money on different super chains like Optimism, Mode, Base, or say you have money on Optimism and Base, and you want to use something on Mode, or you want to lend that on Mode. Right now, you have to go to Optimism, you have to bridge it over, you have to go to Base, you have to bridge it over, and then go to Mode and use whatever app that you would like, right? Like one of the things that I love about the super chain once it's full, or once it will be fully interoperable, is like, I'm thinking you open up your wallet, right? You just click on Superchain RPC or whatever you want to call it, and then you don't have to worry about which chain you're connected to. You see all of the assets listed on all of the different chains within your wallet, and then you can go connect that app on, say, Node, just still with a Superchain RPC, and then do what you want to do, and it bridges over the funds and does all of the kind of background stuff that you had to do manually in one transaction. So it's just you connect your wallet, Superchain RPC, we'll say, select the app, and then it doesn't matter where you have funds. You can bridge those over, and so I think something like early stage, it's like interoperability obviously isn't here yet. It's fully here yet, it's being built, but I don't know, cool things like a Superchain portfolio tracker or something like that, where you can see all of your funds on all of the different super chains. But yeah, I don't want to go into, because I have specific specific ideas, but I don't want to go into too much detail. So I don't want to tell you guys what to build. Like, I want some crazy ideas.
I told Jesse, do not mention any ideas because people will go build it. I know you guys. We want you to be creative. Just
And I'm
know
not
that
creative,
we
by
have.
the way. Like, my ideas are bad.
Oh no, you have good ideas, man. So just know that the judges and the mentors have criteria, right? We understand the state of interop, right? We know that it's early. We know that there's a lot of tooling missing, and that is the point, right? This hackathon is just for that. So if you want to go and give it a try to interop and build new stuff, go feel free to do it. We have, I think it's 2,000 2.5 thousand OP tokens, 2,500, oh my god, OP tokens. Then for financial innovation, it's 4,000 OP tokens. Now, financial innovation, we're going to talk about this. Strong underline and bold letters for innovation. If we see someone just fork a DEX or fork a lending platform, build a new front end, and present it as something Superchain, I'm not going to be impressed by that, even if the protocol is super complex and you deployed everything and you have 1,000 features in your platform. We are not interested in that. I would much rather have a little front end with a small DeFi tool that helps me calculate I don't know, impermanent loss in some LPs that I can just share the contract of, or an aggregator of opportunities on Mode that aggregates different LPs, or on OP mainnet, or whatever it is, right? Or maybe, as Jesse said, you want to go Superchain. Well, what about an aggregator of like Get Balancer or whatever, like Balancer and a few other protocols that are on several chains, and aggregate everything into one place? I don't know, tooling, stuff like that, like original ideas that help us automate things that we do on DeFi on a regular basis. I think small tooling that solves something new and that is something fun and that is something kind of complex to solve in the UX side, and you have to mix different wallets and transactions to make it work. I would much rather see something like that, like a fun little financial project, than a fork of a DEX or something that already exists, right? So don't go overcomplicate things. You don't need a million features. You need just one great user experience flow. If you can land that and solve a little problem, I think you have a high chance of winning one of these prizes. Especially because we're gonna go into your project, connect the wallet, try it out, and if it doesn't work, or if I don't understand what it's doing, then it's like, well, yeah, the pitch is really nice. We like you guys. This concept is really good, but it's hard to give a price to something that doesn't work. or that is not like a clean flow, or that we don't see how it can scale as well, right? So all of these things, you have to take it into account. Remember that judges are human. So if, oh, I love that. You just need one. Great. So yeah, that's basically, remember, judges are humans, right? You can do social engineering to win a hackathon, totally. Now, you need to have a good use case. You need to have a good presentation. It needs to be clear to us what you're doing, what you're solving, and how to use it. If you can nail that, well, that's great. And even better, I wouldn't like you guys stopping here in this hackathon. Usually these hackathons are places to find talent. We are scouting. Jesse is hosting, for example, the Optimism demo days. That I want you to explain to the crowd now, Jesse. That's great. I'm on Mode, and I can help you get, if you tweet about Mode and something you built, we can get you retweeted. We can get you exposure. We could show your whatever you built in our community as well. Jesse, the demo days are super cool. Yeah, how do people go to that?
I I appreciate that. So now that I'm kind of in between grant seasons, we'll say, I started up demo day again, and just actually had two really cool projects on, and like I had them on specifically because I thought that they were building something really cool that hasn't kind of been done before, or they're very aligned with optimism. And so like the first one was a project called Rifflend, that was actually building in the SuperSim environment, the local environment that simulates interoperability. And they kind of demoed how you can connect to any chain, and then you can kind of lend and borrow on multiple chains in one transaction. So it's like building SuperSim. I wanted to kind of showcase them, give them some props there. And then another one called Scout Game, which is for kind of on-chain fantasy sports for builders. And so it's like Scout Game. You can, if you're a builder, you can actually go and apply, and they have certain GitHub repos that if you contribute to, you get rewarded in some way. And then also there's scouters out there like me who buy your, say, builder NFT as well, and so it's like you can get rewarded for that. But I thought those were kind of two novel projects, and I thought that they kind of deserved to have a spotlight on them. So definitely like to see more interesting, novel concepts for sure. But yeah, in the Optimism and Superchain ecosystem, there's always some form of support out there for you, whether it be technical or even social, like getting distribution. But you have to have a cool app. It's like we don't want to see a bunch of demos of the same thing.
Totally. The Scout game is so good. It's super fun. I've seen a lot of people get hooked on it. Hopefully, it gets more adoption. Like it's a very fun game. So yeah, I think we talked about the bounty. So we have that on the tracks, the Superchain interoperability. Again, that is early on, maybe a little bit harder to get into, but still a very valid, price and place to just aim to try and do stuff. It's super early, so there is like any tooling, any experience that you can get in there and show us some cool stuff. Then I think it's gonna do great. And afterwards, again, please, just keep this in mind. I'm going to try and repeat it as much as I can. But after participating here, if you like the ecosystem, if you like optimism and you like interop, you like the product you're building, you like whatever, ask us, ask me, ask Jesse, the other mentors, how you can keep getting support on optimism, because it's hard to find the opportunities. It's not easy to navigate the governance. It's not easy to navigate all the opportunities that are around, which this is an issue. And if you have something or an app that can solve this, more than welcome to help us. But education is very important as well. So education about the super chain and optimism and interop is great as well. So that is down also something to explore. But do ask us for support. This is the main thing. I know now you may be a little bit lost, but the focus, I think it's in 3 areas. One is fun, great applications for users, like end user applications. So that is AI agents that can invest, play social games, Warcast, stuff like that. Gaming, fun little games on Telegram, Discord, with a fun front end, with on-chain gaming, Twitter, Warcast as well, etc. The beyond is all of this is one category of end user apps. Then you have the financial innovation. So again, strong accent on the innovation, bring DeFi solutions or financial solutions of all sorts. It doesn't have to be everything like on-chain stuff of like liquidity pools or vaults or yield farming. It can also be like end user apps, more friendly to the users that are not really familiar with Web3. And if you abstract the Web3 part and use like account abstraction and give a nice experience, this is also financial innovation. Like if you improve some user experience during the finances of a person, right, in their life, that is also financial innovation. Like it doesn't have to be that you build a new DeFi primitive. It has to be that you build a new flow, a new thing on related to finances, right? And there's a lot of things to do in this area. And then lastly, the superchain interoperability, right? Is the three areas is end user apps, fun, gaming, AI, etc. Financial innovation, DeFi, finances, etc. And then superchain interoperability. These are like the 3 places that you can aim. Depending on what you like, it's different. And depending on what you want to do afterwards, you can get different types of support for each of those.
Yeah, I'll just reiterate that. So I think there's definitely a lot of opportunity out there, especially in the DeFi category, to improve the end user experience. Like yesterday, I was trying to explain to a friend it's how to provide liquidity and then see how much rewards you're getting, and impairment loss. And so it's like all of these things, whenever you're kind of a newer user or not kind of a pro yet, they're very confusing, and you have to read dozens of pages of documentation and then make your own spreadsheets to figure out or show what you want to show, and kind of surface this information that's important to the user. So I think things like that would be valuable as well. It's like you don't have to come up with a new DeFi primitive in 3 days and a half. It's pretty hard.
Yeah, totally. And one other thing that I would add as well is if you don't finish your product, but you think you have a great idea and you love it, build as much as you can. Build an MVP, hard code, whatever you can, and just try to show us an experience. Because if you have that, right, in the future you have the governance where you can maybe ask for a grant, depends on if you qualify or not, right? But then you have retro funding. You have the demo days with Jesse. You can get exposure with Mode, with Base, with a ton of these ecosystems that I know, and we can help you connect as well. All of them can give you a little bit of support in different fronts, getting users, getting exposure, getting funding, covering, I don't know, infra costs, etc. For example, and this is for Mode specifically, if you build cool AI agents that are doing something on Mode or that are social on Mode or whatever, we are heavily pushing for that. We need that. We need cool developers that have great ideas building AI agents. And I know that we can help you a lot, right? Jesse knows he's been scouting for apps on the Superchain for like more than a year. Like every time I see you, you're asking people what they're building, to show you their products, to show you what they're building. So there is support, there is hunger for end user apps. So take advantage of that. Take this hackathon as a little bit of time to just focus on one product and build as much as you can. And in the meantime, also like you can make some nice money, some nice OP tokens to even keep working on your product later on. I think that's
Yeah,
the best focus we can put, right? Yeah, Jesse. Yeah.
Yeah, I agree. And I'll reiterate, super important to reach out to us and like use us as resources. That's why we're here. I think that a lot of things in the Superchain ecosystem and optimism ecosystem in general, people find through connection. So it's like there's random Telegram chats, right, for the Super Sim. That's how I found out about a couple projects building in the Super Sim. There's other Telegram chats for the new token standard. Optimism has an R&D Discord. There's people like me out there who do demo day. There's other people who make content as well. But it's like you need to kind of reach out and make connections for us to kind of tell you about those things and those the resources out there to help guide you.
Yeah, I will send a message in the Hackathon Telegram group chat with a bunch of links. I'm gonna just select a few links, Jesse as well. Like we're gonna collect a few links for governance, grants, interop, etc. So you have all the information that you will need and the resources. I'm quite deep into the whole interop stuff, so I can help you, like guide you in there. Don't ask me deep development questions, or do ask them. I'll help you find the answer. That's the key thing. Um, I would like to also talk a little bit about like because Jesse, OP mainnet, right? OP mainnet, Optimism, and Superchain confuse people, right? They ask me, hey, but wait, is mode a layer 3 on top of Optimism? Is it like in the same level of Optimism? Is it like, does it settle to Ethereum? Like what's going on here? And also people get confused about like the Optimism governance versus the OP Foundation, right? Um, I'm gonna try and give an explanation about Superchain on the technical side and everything. I'm gonna ask you, Jesse, that you have a more clear concept to define like the OP Foundation versus the governance and what they do, and maybe mention also OP Labs a little bit. So I'll try to keep this short, but the three categories that we talked about in this hackathon, right? One of them is involved with the OP stack and interoperability. As we mentioned, Mode is built with the OP stack. So Mode, Base, Zora, WorldCoin, Redstone, all of these layer twos, including OP mainnet, are on the same level, right? OP mainnet is the example use case of the OP stack. OP mainnet, Optimism mainnet, the chain, was the first like use case showing what the OP stack could do. And then all of these other chains are deploying the same stuff. What does this mean? That all of these chains are EVM compatible. So if you've deployed a contract on OP mainnet or even on Ethereum, you can just copy that code and paste it and deploy it on Base, on Mode, and all of these chains. There is a few little changes that maybe you will have to do if you deploy it on Ethereum that may not work on OP, but it's a few very specific use cases. All of these chains use Ethereum as their settlement layer. This means that all of the layer twos that are on OP, running on the OP stack, are using Ethereum to save their state, right? So OP mainnet is the same as Base, Mode, etc. Why do we need interop? Well, because right now things are getting fragmented, right? Velodrome or any DeFi protocol is deploying on Mode and also has to copy paste that code and deploy it in 10 other chains. So this is a problem, right? This is where interop comes, and it's a shift in how you think and how you develop applications. This is the interesting part to me. If you like architecture, if you like this system design, do look into interop because it changes how we build applications. Why? Because now, instead of having to copy paste all the contracts in each of the chains, you can deploy a set of contracts on every chain, but these contracts are different because they can communicate with each other and send tokens from one chain to another. So what can happen is a user on base can start a transaction that gets executed on Mode because the liquidity is better, because there's less slippage, because whatever. Okay, so this enables for more interesting application design where you may want to have liquidity in different layers, but you could move the liquidity around and perform swaps wherever that's more convenient, right? Why? Because the cross-chain messaging is really cheap and fast. So I'm just gonna leave that there. I know it's complex. Maybe you have no idea what I'm talking about. Maybe yes, but this kind of shift in mentality for interop is gonna be needed and a lot. And there's not a lot of people just thinking about how to use this into applications. So it's a big opportunity if you want to jump in and work on something new. Thinking about how to design these complex applications and interoperable applications is, yeah, it's a great place to be working in. Yeah, just that. I don't know, Jesse, if you want to jump on the foundation versus optimism governance, because people get scared about the governance, you know? It's
What nothing to be scared of about governance, just very complex and confusing. It's one of those things where in optimism there's an iterative governance model, meaning that we have seasons, and each season's like what we fund, and our kind of North Star metric changes. And so it's like, several months ago, the kind of North Star metric was bring developers into the ecosystem. The North Star metric kind of for this next season, which isn't final, is looking is moving sort of more towards having a interoperable stage one chains, doing a lot of volume, we'll say, per month in cross-chain transfer. So kind of incentivizing that liquidity and the chains interacting. As for like governance versus the foundation, right? As far as funding goes, it's actually we're trying to do better and move it under the same kind of North Star metric kind of umbrella, where it's the set or the stage one interoperable chains doing 250 million per month in cross-chain asset transfers. That's what it is. The foundation kind of missions align with that higher level intent or North Star metrics or North Star metrics or North Star metric, as well as the two different types of funding: the retro funding, which is the retroactive rewards, getting rewards for impact that you've already had, and the governance fund missions as well, which is the Grants Council.
great. And the grants council are the people that you need to convince in order to get money for a grant. So you need to justify, yes.
The Grants Council has, just like this hackathon, right? There's a scoring rubric. The Grants Council also has a scoring rubric that each counselor gives your application a score on. And so it's like you try to be as impartial as possible through that scoring rubric.
Well, that's what
don't social engineer grants or winning hackathons.
I mean, try to do it. We're building the system so that doesn't happen, right? Like that's why governance is so complicated. Is that there's all of these systems in place and the rubrics and the processes so that the grants council doesn't just like randomly pick whatever they think it's best, right? It's a whole process where you present your case on why you think you should get that money, how much you should get to achieve your goal, and how your goal is aligned as well with the whole optimism and Superchain ecosystem. So yeah, the best recommendation I can give you if you want to get into governance is two things. One, the governance calendar. So if you go to the Optimism forum and to the Get Started section, you can get the, oh yeah, that's great, optimism.io, that's the website. But we will, oh, it's in my mind. Yeah, there we go. If you go to the governance forum, you can download and add the governance calendar, which has helped me a lot to see the different seasons, and also a lot of calls where you can just go and ask questions. You can get feedback on stuff. You can ask how you can, I don't know, you can share an idea and they can tell you where it's better to just post in the forum and what's the best approach to build it, right? So I would say add the governance calendar as one. And number two, for example, L2Bits is hosting every week, I think, governance office hours for Optimism. So you can just go there. Christoph is there. Sinkas is there. I usually hang out in there as well. Jesse has been there a few times as well. So you can just go there and ask questions and get recommendations from experts that are all day there, right? Jesse,
I
I want
agree.
people to bother you. That's what I want. I want
And
people messaging you.
me too. I love being bothered actually. That's how you learn things by having people rant to you about what they don't like about the ecosystem or they don't like about something. So I love listening to those rants. It helps improve everything. But also if you join the Optimism Discord, there is a bi-weekly office hours in there as well. So you can join, ask questions. But yeah, there's a lot of resources. I highly recommend putting the Optimism Gov calendar on your calendar so that you can check out events or even hop in the Discord. So I'll try to be quick about this as well. So one of the things that I did for Optimism at the foundation was like contributions management. So at Optimism, there's a lot of these different kind of tracks for contributors. And so it's like if you hop in the Discord, people can help guide you down those tracks. So it's depending on what you like. It's like if say a number nerd or I'm in the analytics, I like building dashboards, I want to do something there. There's resources that can guide you in the right direction as far as how to contribute, most likely sending you to open source observer, where they can kind of guide you as far as contributions go. If you like answering technical questions about optimism, and it, if you guys go down the rabbit hole and start to get red pilled, there's a separate contribution track even for answering technical questions. There's a contribution track for monitoring or doing kind of the Discord moderation. And so usually there's something for everybody. You just need to get out there and talk to people.
Completely agree. I think
So I'm also
yeah.
reformed. I'm reformed. So I don't think, yeah, my name on here is Jesse J. Rocky. I am reformed normie on Telegram. You can see me in the end of the Telegram chats there. Don't be
I had
afraid to
so many
ping.
problems with that, dude. I was like, Jesse, where are you? And then I remember reformed normie. That's it. Yeah. Well, I think we're on time. I hope this rant and this crazy talk was helpful to you guys to just know what's out there. With Jesse, we thought that the optimism ecosystem is so big that in less than an hour explaining everything and these three tracks was a little bit too complex. So we wanted to give you a map of like all the possibilities and things that are out there. So this is thought, so you reach out to us in the groups, like please ask in the group chats whatever you need, whatever guidance you may need, just let us know and we can help you get a North Star and maybe get better results for the hackathon and after the hackathon as well. Just know that at least for me, I'm not thinking about just this hackathon. I see this as one activation thing that then can continue and will bring you a lot more opportunities. So yeah, that's all on my side. Jesse, any closing remarks?
Nope, that's very well said. I think it's going to be helpful whenever we drop a document of some links to the things that we just showed, so you guys can go down the rabbit hole as well and ask questions.
Yes, we will. We'll share the list of links that we have now in the Telegram chat, so you can all go down the rabbit hole. And yeah, that's all. Last thing, thank you Aleph for this hackathon, and thank you Optimism as well for the bounties and the prizes. Both, make this happen, and we have this amazing space for innovation to play around. So you guys can just play around, build cool stuff, get supported, get money, get exposure, and even build cool stuff later. So it's like everyone wins. It's great.
Hell yeah, that sounds nice. Now I wish that I was a smart contract developer so I could participate, but I've never written a smart contract in my life, is the ugly truth.
You could. You could soon with AI. You'll get a ton of help there. You'll see.
It's a good show. I love that.
Yep, I think we're done.
All right. Oh, the stream is off.
It's not. We're still live, right? We can dance for the awkward silence if you want. We can dance in the distance. Yeah.
Yeah. Drop some comments in if you have any questions. We can answer them. I like that.
We. I have
Where did-
this thing with with the ambassador group at Mode. Whenever I ask them to give updates or whatever, and I'm waiting for someone to just pick it up, I start dancing to avoid the awkward silence. So just yeah.
like
There we go.
Well, thank you so much, Fed and Jesse. It was amazing to have this space to hear about the opportunities and possibilities the optimism ecosystem offers. So thank you. Thank you for the insights, the tips, everything you shared. Thank you.
Yeah, thank you for hosting us.
Wow.
Thank you very much. Well, see you in the next one. Bye.
See you.
Good luck.
See you guys.
Well, and next at 3 p.m., we will have our last speaker for today, Kat McGee, with What the Fuck is zkSync Hands-on Coding Workshop. So stay tuned, and we will be back at 3 p.m. Hi there, welcome back, welcome back. Well, here we are with Kat McGee. Kat McGee is a DevRel at Aztec Network, the first privacy-focused layer on Ethereum, and we will be learning what the fuck is zk, hands-on coding workshop. Remember, if you have any questions, hi there. if you have any questions, feel free to send that through Telegram, and we will be answering as soon as we can. So, well, Kat, the stage, it's all yours.
Hey everybody, thank you so much for inviting me. I'm really excited for this, actually. This is going to be fun. Yeah, I'm Kat. So if you don't know me, I do developer relations at Aztec. As we talked about, as we mentioned, it's the first layer 2 on Ethereum that's all for privacy. But we also have an open source language called Noir that lets you write circuits. So that's what I'm going to talk about today. If I can figure out how to share my screen. I'm going to assume my screen is sharing. But yeah, so today we got a few things that I'm going to cover. The first thing is just what the fuck is zk. I'm going to talk a bit about just like privacy in general as well, and the different kind of privacy tags that exists and why it's important and why we're building this and why Noir exists. And then I'm going to talk like a bit about zk and intuitions that you need to kind of be aware of before you start writing zk programs. We're trying to make Noir as easy as possible to use, but I think it's still important to kind of understand like a little bit about the different entities involved in zero knowledge and circuits. And then we're going to dive into actual coding. We'll write a circuit in Noir, and then we'll hopefully write a couple of other circuits in Noir and explore everything that Noir is. If you're familiar with Rust, it should be fairly simple for you. It's going to feel very like writing Rust. We're just going to do that from scratch. So like we'll install it and go into it from there. And then we're also going to deploy a verifier on-chain on a local network and see what that looks like. See this perfect marriage of zk and blockchain. So before we go into it, I know you've probably heard this like over and over again for this week. I think this whole week has been like pretty obsessed with privacy, which I love. And I know you're like learning a lot about zk and stuff as well. I know Zama is a sponsor. So that's really awesome. But I just think it's like super, super important to just talk about it as much as possible, especially because like in Argentina right now, I feel like this is a case study that will be looked upon for the next like decades of like what happens when a nation embraces crypto. So I think it is really, really important that not only that like, you know, we embrace crypto, but also privacy, because privacy is such a normal thing. Like I'm wearing clothes right now. That is a privacy thing. I have curtains. That is privacy. Like we are so used to this in our regular life. And it's just a really important thing that we have it in the technology that we use as well. These are just like some examples that I wanted to talk about. So like a lot of people are building blockchain because they like transparency and they think that we should be at the point where everything is transparent and we can see what everybody does. But like there are things that we just kind of want to keep private, like gifts that you buy people, or like if you're late on something, like people fuck up all the time. You're late on a payment and then the entire world can see, and all the people that you hate can see you like messing up. I also think it's been really interesting that like Elon has made likes private on X, and I feel like everyone has changed how they approach likes. Maybe you're using them as like bookmarks or things that you actually like, and it's less of a like public, like yeah, I like this, but more of a like how you're using it in private. We just have a different world in our private worlds and our public worlds. And then there's also like the cypherpunk side where governments can just super easily change rules. They're centralized and they can do that. And like we saw that with France earlier this year, where they decided that Telegram should give up all the information to them and see all their chats. And Pavel was arrested. And that's just like crazy that can happen. And we just need to have privacy default in the tech layer. Quark ID as well is like another example. I know they're on zkSync, and I think they've got like circuits or something for privacy. But if it wasn't private, and then they could just like every time you kind of verify your identity to like get a drink at a bar or something, like that information is shared with insurance companies, and then they can charge you more because it's like unsafe. Like there's just so much involved, and without privacy, if we're building blockchain, this completely transparent distributed network, then we are building the next surveillance state. And it's kind of crazy. So I think it's really important that we think about this. But I think it's a lot simpler than all that. Like realistically, if we want to realize the actual use case of blockchain, which is like we have real world ownership on chain, you know, like your cash is yours, your assets are yours, your home is yours, your car, like supply chains, like all of those things can exist in the blockchain, and that's real like ownership of it. But the only way you can have real world ownership is if you have some sort of identity. Realistically, like we still need to like comply with some sort of regulations. You can't have a completely anonymous ownership of a home. And so we will need some sort of identity on chain, but you're not going to put your passport, your address, everything you own, every transaction, all of your net worth on a public network. And that's just why we need privacy. It's just like such a normal thing. Like it's not some sort of like fuck the government thing. Like it's literally just we need privacy and technology we're building. So thankfully these days, there's lots of people building privacy technologies. I know you heard from Zama earlier, which is fully homomorphic encryption. It's also multi-party computation, trusted execution environments, and obviously zk, which I'm going to get into now. So before we get into the coding, just kind of want to like get some intuition for zk. This is a diagram that I made that is not very good, but I'm going to explain it. So this is the Alibaba cave. I was going to check that you guys can hear me. Has anyone said anything? No. Okay. Cool. Wait, do we have any questions yet? Also no. Okay, awesome. Yeah, this is the Alibaba cave. This is like a really common kind of thought experiment for thinking about what zero knowledge is. There's two entities here. We've got this guy here. His name is Victor. He's a verifier, so his name is Victor. And we have Peggy, who's a prover. And these are the two entities involved in any sort of thing related to zero knowledge. We have this cave. It's supposed to be a cave. This purple circle is a cave. And there's two paths into the cave, and there's a gate here. A gate that has like a secret code in order to open it. And Peggy knows the secret code of this gate. Victor doesn't. And Peggy wants to prove that she knows the secret code of this gate without revealing what that code actually is to Victor. And she also doesn't want to tell Victor like where she is in the cave and where she's getting in and stuff. So they've developed this system where Peggy goes into the cave and then Victor's like, okay, we'll come out of either path A or path B. And she comes out of the path, and then Victor either thinks like, okay, well, she either opened the gate with the secret code that she knew, or she just happened to be in that path anyway. So then they repeat this millions of times, and she gets out 100% of the times. It's fairly obvious that she knows the password for the gate. So she has verified, or she has proven that she knows this gate, the code for the gate, without telling Victor what the code is. So that's kind of just like Victor has zero knowledge, but he knows that Peggy has the knowledge. Something that's kind of like interesting as well is that this is an example that was really used before snarks came about. I'm sure a lot of you will have heard what a snark is, but it was developed in the 2000s. zk has been around since like the 80s, but snarks is like a succinct, non-interactive argument of knowledge. So it makes zk like way faster and actually usable. And the way that it works is instead of Victor saying B, there's this other thing called the trusted setup. It's not interactive anymore. So Victor doesn't have to say BA, BA, BA and verify over and over and over again until he's happy. But there's this thing called a trusted setup. This can be like decentralized. It's just like another third entity. And then that is what introduced the randomness. So this third entity is going to say B or A or B or A, and Peggy's going to come out of the right gate. And then this entity is going to tell Victor like, hey, this is all the information that I have. And Victor's going to say, okay, cool. I can verify that she actually knows the code of this gate. So it's kind of interesting, just like to see what snarks are, and that's what we use as the default backend of Noir. So I think we can talk about Noir. I don't know why I wrote this in Spanish, but Noir is the zk DSL for everybody. zk DSL means zero knowledge domain specific language, so it's a language specifically developed for writing zero knowledge programs. We kind of call it like the universal language for zk, and there's two reasons for that. And the first one is that it's super familiar syntax. Like, this is the easiest way you're going to write a zk program. If you can find an easier one, I will send you USDC, because this is the easiest one. It looks like this. This is a full program it's a full zk program in Noir, and we're going to code this in a second just so you can like run it all and see how it works. But basically what's happening here is that we're defining a main function. Every function has to be called like main if it's the main function of the Noir program, and then we passing into parameters, X, which is private. With like Noir, everything is just default private. So if it's a private variable, you don't have to specify that it's private. You only have to specify if it's public. So we're passing in X and Y. X is private. Only the prover knows this information. Y is public. So both the prover and the verifier will have this information. They're both fields. Fields are kind of a complex cryptographic thing, but it depends on the proving backend that you're using, what they are. But the way that they feel in Noir is like working with ints or working with hexadecimals. So you can do some calculations on them, or you can just you can do comparisons and stuff as well. That's what we're doing here. We're asserting that X is not equal to Y. And as long as that happens, as long as that goes through, then the proof is generated. So it's like if the circuit succeeds, then you get a proof. It's as simple as that. It's also proving system agnostic, which basically means that like Noir can be used with any sort of proving system that you have. So we're using something called Berettenberg right now, which is like the code version of Plonk, which you might have heard of, but it's just like a bunch of mathematics that you don't need to understand. But yeah, Noir can be used with anything. So it's like you can fit into like a lot of different systems, which is really interesting. And the way that it works, I get this question a lot. Noir compiles to ACIR, which is abstract circuit intermediate, not immediate. I wrote that wrong. Intermediate representation. And then it's fed to this thing called the ACVM, which is the abstract circuit virtual machine, which then like translates that ACIR into whatever mathematical thing that needs to exist for the proving system to work. So we're going to be using Berettenberg. We're going to install that as well as Noir, and then use Berettenberg to generate proofs and verify those proofs as well. I'm going to check if we have any questions. Okay. All good. So if you want to follow along, we're going to be like live coding. You can go to this link or scan this QR code. It's just on my GitHub, github.com/catmcgee/Aleph. And there's a bunch of different like code stuff in there. It's just in here. So there's 2 branches here. The main one is like the code that I'm going to be trying to code right now, but I might do it slightly differently. And the starter branch is where we're going to start from. So if you want to code along, I recommend cloning this and just checking into the starter branch and then coding along with what we're doing here. There's also like, if you miss this workshop, all the instructions are here in English and Spanish. So you can like follow along and learn Noir in 5 steps. But yeah, I have it here on my VS Code. I'm hoping you can see this. I think you can see VS Code. We can see we have 5 different steps here. So we're going to go into step 1. And there's nothing in here right now except this README, which just tells you how to install stuff. So we are going to, I'm not going to install Noir, but if you need to do that, you can go into this README and just do like this command. Actually, that should be different though. Oh, why am I not on a get repo anymore? Okay, whatever. Yeah, so you can install Noir and then you can install Berettenberg as well, but I'm not going to do that. So basically, we are going to create a new Noir project inside here. Oh, I know what's going on. I'm in a deleted repository. Okay, hold on. Okay. All right. And then I'm going to do nargo new, and let's just call it step 1. So nargo new, and then whatever you want to call it. And it's created a directory here, source directory with the main inside of it. We saw this already in the presentation, and it's got a test as well. And it's also got this nargo toml. If you know about Rust, this will be familiar to you. It's also like cargo toml. But this just tells like the compiler some information that it needs to know and the different versionings and stuff. So we can see we have a test here. You can write any sort of test and just like put this on it, and then you can run it by running nargo test. So free one nargo test. I'm not on the right directory again. Nargo test. We can see that it passed here, and I'm going to zoom in. If we uncomment this, and we're actually passing to things that are the same, then this should fail, and we should be able to see in here that it fails. Yeah, we say one test failed because it cannot satisfy the constraint. This is like a constraint. So let's get rid of that. And then we can also generate some proofs. So in order to generate a proof, we have to generate a prover toml, which is going to be the private inputs that we feed into our witness. So witness is just like who Peggy is, like the prover. So she has all the private inputs. So we can do nargo check, and that creates a prover toml in here with everything set up. So we can just fill them out. So we can put in like our numbers in here that we want to be not the same. So like 420 and 69. And that's going to be what we generate our proof with. And then we have to use Brettenberg to actually generate our proof. Before we do that, we got to create the witness. So we can do nargo execute witness. We're pretty much making Peggy here. And then we should have a target directory open here with this compiled circuit. So this is just like a bunch of JSON. This is the compiled circuit. You can have a look at it if you want, but it's just how our compiler is going to understand the circuit. And then we also have this witness. This is in binary, so you can try to read it, but I don't think you're going to be able to understand what it's saying. But Brettenberg understands, and that's the only thing that we care about. So now we're actually going to generate the proof with Brettenberg. So we go into our terminal and do bbproof, and then we pass in the compiled circuit. We pass in the witness, target witness, and then we also specify the output directory for where we want our proof to go. So we'll just put it in proof. And if everything is good, we should see a file here that is also binary, and it looks way more scary than the witness. You can also see this in hexadecimal. We're going to do that a little bit later, but yeah, this is what it looks like for now. And then we can verify that proof as well, also with Brettenberg. So if we go back into our terminal, before we verify something, we have to generate the verification key. So we do bb write bk. We pass in the circuit again. Step 1 JSON. And the output for where we want our verification key to go. So let's just put it inside target vk. Here it is here. And then we can actually verify it with that verification key. So we do bb verify. We pass in the circuit again. Whoops. Target. We pass in the verification key. And we also pass the proof, because we're verifying this proof. Target/proof. And if everything works, it shouldn't give you anything. So it's quite anticlimactic. But we've just proved it and verified the proof with Brettenberg. We can just say that, like, say we typed this wrong, then it's not going to work. But yeah, so this is a correct verification. So we've got our proof and we verified it. And it looks very scary. Scary, scary proof. But that's kind of the basics of Noir. A very simple circuit that was just proved and verified directly in the terminal. But if we go on to step 2, this will be a little bit more intermediate. So in this circuit, we can say it's for like a football club or something, and we are taking in a member and we're proving that they are above 18 and that they are they have a passphrase, like the correct passphrase for something. So the way we can do that is by hashing a passphrase, and then we can pass the passphrase and then hash it and see if it actually matches the hash that we already have saved, because you can't like go backwards from a hash. So no one will be able to see what the passphrase is, but you can check that the passphrase hashed matches the passphrase hash that we have saved. So we're also just going to, like, you know, do some printing and stuff in the terminal so you can see what that looks like, and we'll play about with some other types. So let's say we have a struct of a person, and they have a name, and it's like a string. If you're writing things with zk and with Noir, you can't have like arbitrary lengths of things, because the size of the circuit has to be known at compile time. So you can't have like arbitrary lengths of loops or arrays or like lengths of strings and stuff. So we can just say that there's a name of like string length 3. We can also have an age, and that can be a U8. You can work with integers and stuff. In Noir as well, we have lots of different types, which is pretty exciting. Whoops, didn't mean to click that. And then we can specify like a minimum age or something of 18. Wait, okay, I'm gonna check. Everything is good. Okay. I'm always so paranoid because I can't like see anybody and I can't hear anything. So I'm scared that I'm just gonna cut off at one point and I'm just gonna keep going and not know. But yeah, so we have minimum age is 18 and we have this like person struct that we can use. And then in this main function, let's take in the member, which is going to be of the type person that we defined. And then we'll also take in the passphrase or the passphrase, which will be a field. So first thing we probably want to do is assert that the member's age is equal or probably more than or equal to 18, which we've already said here, minimum age, so we can change that. And then we're also going to want to like calculate the hash of this and compare it with a hash that we already have to make sure that the passphrase is right. So in order to play with hashing, we have to use a dependency. So I'm just going to get the standard library in here. So I'm just importing the standard library. And then what I'm going to do is like generate a hash somewhere. I've already done them up here. So this is a hexadecimal representation of a string, and the string is VAML messy. So we can use that as our hash, as our passphrase. And when we've hashed it, it turns into something that looks a bit like this. Actually, before we do that, we can play with this a bit. So in our tests, we're able to print things. So we can create a test that like gets the passphrase hash. Why is this so hard to say? Gets the passphrase hash. So we can do the standard library hash, get the Peterson hash, and then we're going to hash the passphrase that we have, which is this. No, it's not. It is this. And this function, oh, wait, shouldn't be in a string. This function takes an array, so I'm just going to pass a 0 as well, which is fine. So we're going to also print that. So we'll do let's hash is that, and then we'll print line of the hash. Now I want to run Narger test, as long as I'm in the right place. And I put in show output, then I'll see that the passphrase hash is this. So now we can use this as our hash in this function. So we can do let passphrase, let correct passphrase hash equal to this. And then we can just check that their passphrase is right by hashing it and checking that we have the correct passphrase. So what we're going to do is pretty much the exact same thing as we did here. So let passphrase hash. Standard library hash, Peterson hash. We'll pass in the passphrase and 0. What's this error? Yeah. And then we want to assert that the passphrase hash is equal to the correct passphrase hash. If all that is good, then the proof will be generated and they can join our football club. So let's create a test for this, just to make sure everything is good. So we want to say the passphrase is something we've already got up here, hexadecimal for VAML messy. Then we don't need the hash phrase. Then we're going to create a person. So I'm a person. My name is Cat, which has 3 letters in it, so that works with our string. My age is 26. Fun fact, people don't know that. Why is this not working? There we go. Okay, gotta use, I didn't actually know that. Gotta use a double speech marks thing. All right, I gotta specify this as a test as well. And then I can run this test and hopefully this all works. Cool. And we can also run the prover as well. So if we do an argo check in here, it's gonna generate our proof system in our prover toml. So our passphrase is just copy it from here. And then it's creating a member here. This is the name of our struct. Age 26. Name cat. And then we can, I think we already generated a witness. Generate witness. Ooh, okay. That's really weird because it still created the witness, but it gave me a bunch of errors. We've been having some issues with Noir today, so I'm going to ignore these errors because I don't know what they are, and it still worked. So let's just see if this works. We'll do bbprove, pass in our circuits, pass in our witness, and do the output as proof. Yeah, it's still proving. All right, cool. So I've just generated proof that I am over 18 and have the passphrase of Bamble Messi, so I can join this football club. Cool. Are we good? Yeah, if you have any questions, by the way, just like ask them in the Telegram, or not the Telegram, in the Twitter or YouTube chat, and I can see them. Feel free to interrupt me. Okay, step 3. In this step, we're going to learn a bit about optimizing circuits and a bit about unconstrained functions. So everything in a Noir function is presumed to be constrained, which basically means that it's proved. Proving something is quite expensive, as you probably have heard. That's kind of the main argument against zk, is that it can be really expensive to do and it takes a lot of time, a lot of computational power. But you can actually work around that a lot by doing things unconstrained, so you don't generate proofs for them, and then proving that they're actually right in a constrained function. And a really good example of this is a square root. Square rooting something is really, really computationally expensive, but squaring something isn't. So what we can do is we can square root something in an unconstrained function, and then we can square the square root in the constrained function and check that everything's good, and then our circuit should be faster. So I'm going to do that here. First thing, I'm just going to write the square rooting thing in our main function, and then we'll run it and we can check how efficient it is, and then we'll do it unconstrained and then see the difference. So there's a famous square rooting algorithm that I'm going to use. So we're just going to do the approximation of the square root, and we'll define that as num, and then we're going to do better approximation, which is going to be this plus 1 divided by 2. And we need to have these as mutable. Everything is presumed to be immutable, but you can specify that it's mutable if you just put mute in front of it. So these are going to be mutable. And then we're going to do a for loop. With Noir, you can do for loops, you can do if statements, you can do all the regular coding stuff. But you cannot have a loop of a undefined size. So we're going to just say that we'll run it 10. We'll run our loop 10 times. So for I in 0 to 10, we'll put approx as better approx. And then this is the famous algorithm thing. Approx plus num divided by approx divided by 2. As far as I know, that is what it is. This is the square root algorithm. It's just going to do this 10 times, so we get as close as possible as we can to the square root. For bigger numbers, you might have to do this 100 or so times, but we're just going to keep our number small. You can use I here, but it's going to give me an error that it's unused, so you can also just change it to an underscore. Then it's basically telling the compiler that this is an unused variable. And we're expecting to return a variable here. all the return values have to be public, because pretty much the way it's working in the back end is that like it's a public input to the circuit. And it's saying we're expecting this to be back. But for the sake of developer simplicity, we're just calling it a return value. So we're going to return better prox at the end of this here. Yeah, we can test our square root in our test main. So let number the square root equal to 9. And then we'll call this function pass number to square root, and then we're gonna make sure square root of 9 is 3. So we'll make sure that square root is equal to 3. All right, so let's see how this works. Nargo test. Cool. So this square root function did work. But so far it is constrained. So it's going to be taking up a lot of computation power. So what we can do to actually test how much computation it is, we have to compile it. We can see our compiled circuit in here. And then we can run something called BuidlGuidl and pass in the compiled circuits. Gates is like a gate count of a circuit. So if you think of circuits, like we call them circuits because they're doing the same thing as a regular IRL circuit, and they have gates, right? And you want a small number of gates as possible because that's going to be what's efficient. So you run BuidlGuidl and you can see all the information for like how many opcodes it is and stuff. ACIR opcodes, you generally want this to be small. Some opcodes are more computationally expensive than others, so this number is kind of a little bit iffy sometimes, but you do want that to be small. Circuit size is really what we care about. So this is like our gate count here. So currently it's this. So we can try to get that down. If we go back into here and we basically just turn this into an unconstrained function by saying an unconstrained function square root. Let's call it that. And then we will just square it in our main function. So we'll do main, function main. We still need to take in and return the same thing. And what we're going to do is let square root equal the square root. We're going to call this function and pass in our num. And then we're going to assert that the square root multiplied by the square root is equal to the num. And that's basically saying, yeah, our square root is good. And then if all that is good, we'll return square. No, we'll return square root. So now we have this as an unconstrained function. We can still run the test, except we need to call, we don't need to change anything. Run our test and that pass. So the square root's still working. We can even change the number to be like 144 and 12. Okay, I still know what I'm doing. And if we change it just to prove that, yeah, that's going to fail. Yeah, cool. So now we can compile this again. And this should override what we have in here. And then we can call BuidlGuidl on it. Oh, wrong thing. This is supposed to be a B, not an O. Yeah, we can see our circuit size. It went from, what was it before? It was like 3,000 something, 3,059, and now it's 2,810. And our opcodes have gone down significantly, so that's really nice. So we just optimize our circuit. And there's kind of cool ways to get around it, like different multiplications and divisions. Like if you really want to get into it, I think divisions are more computationally expensive than multiplications. You can also like play around with that a bit, but it's kind of fun. And also within unconstrained functions, you are a little bit more free in terms of like the size of it. So you can do like breaks and continues and stuff. So like say if our number ended up being a number we don't like, I don't know, we don't like the number 13 or something, we can say like if the number is 13, break. The it's never going to be 13. But if we do like, if we change this to I, and we do something like if I is equal to 4, we can do break. And then this will actually fail. Maybe it won't. Okay, so it works. Cool. But yeah, this is just broken in here. So it just speeds it up even more in non-constrained function. So that's non-constrained functions. Yeah, now we can move on to step 4. How much time I got? Cool. This one is pretty exciting. So in this step, we are gonna verify our proofs and generate our proofs with JavaScript rather than doing it within Bredenberg. So Bredenberg, you can do it in the CLI, that's all awesome, but for an actual use case, you might want to use it with JavaScript. So you can generate proofs within a browser with Noir, which is the only, as far as I know, the only language that can actually do that. Like completely in the browser, you can generate proofs. Any browser, sometimes on the phone, depending on the backend that you use, which is really, really insane. That's so cool. Like in a phone browser, you can generate a proof. So yeah, people say it's like too computationally expensive, but nah. Anyway, so we're just going to use our basic circuit for this one, the one that we've seen before, take an X and Y and prove that they're not the same. I've already gone ahead and like compiled it and stuff. And then we have this index.js, and this is going to be what we're working from in here. So yeah, you have to install these 2 packages, Noir-Lang backend Bredenberg and Noir.js. I think this is the only backend that we actually have in JavaScript right now. So you're probably going to be using this. And yeah, Noir.js. And then I'm also importing the circuit that I compiled here. And then it's really, really easy to do. So what this is actually doing is that we are generating the proof and then putting the proof in its own file so that we can actually see what like a proof looks like in hexadecimal and not just mess Bredenberg stuff. So we defined our backend, just create a new backend, Bredenberg backend, and we pass the thread counts. If you have a more good computer, you can do as many threads as you want. And then we've also just like defined Noir as Noir main. So then now we're going to define the inputs, the private and the public inputs for this thing. What do we need again? Yeah. So we do const input. We have X. Let's do our normal one. X is 1. Y is 2. Only the prover is going to know what these are. You can also like take them from like a client side or something and not put them in the code because everyone can see this code. So it's probably not a good idea. Then we can create the witness. So what we're going to do here is const witness. And then we do, remember, because we were writing like Noir or Nago execute. So we just do the same thing. With Noir execute and pass in the inputs. And then we can actually generate the proof. Whenever you do this, so you're going to get back the proof and the public inputs, and then you can pass those public inputs to the verifier. So we'll do const proof public inputs equals await. Now we're using Bredenberg for this, so we'll do backend. Let's just generate proof, and we pass in a witness because our witness has the private inputs. So I think this should be good. Oh yeah, then we need to verify as well. So what this is doing here is it's just like turning our proof into a hex and then writing it to a file so we can see what it looks like. And then we can verify our proof. So we can just do const verified equals with backend verify proof. We pass the proof and the public inputs. So we'll do proof. What do we call it? We call it proof. And then we'll pass our public inputs, which I think are also just called public inputs. And then we can like console log if it's verified. We'll pass this. This is just a Boolean. So it should just say true or false. So if I go ahead and run this, I have a package JSON here. If you want to run this yourself, I've got you can just read the README. It tells you what to do. But there's a script. This is going to run it if you just run npm run start. So npm run start. And undefined. That's not good. Okay, so we do not have a verified proof right now, but we do have our proof in this JSON. So this is what a proof looks like. This string, this hexadecimal thing here, this insanely long thing. That is a proof. So this is what, like if you're using Solidity and stuff, this is what you're going to need to pass into Solidity. Then our public inputs is an array, but we only have one public input, which is 2. So it's in hexadecimal again. So you just see 2 on the end. I wonder why that didn't work. Okay. Okay, I'm going to get to this later because I think I'm actually kind of running out of time. Do we have any questions? No. Okay, cool. All right, step 5. This is probably the one that's going to be the most useful to all of you. So the cool thing about zk is that you can verify it anywhere, right? You can verify it in the browser, you can verify it in Node, you can verify it on a server, like whatever you want to do. But then there's a trust assumption that's set up for that server. And you're trusting this verifier to actually verify the proof and not just say it's verified or just say it's not verified for whatever reason. Like people can change what their verifier is and where it points to. So that's what's so cool about having the verifier on chain. You still generate your proofs locally, like client side. The proof is the only thing that goes anywhere, but those private inputs are completely just yours. But then you send it to a blockchain. You send the proof and the public inputs to the verifier, which is just a Solidity smart contract. So we can automatically generate the verifier contract, and you'll see why it's automatically generated because it's really funny. So I've got in our step 5 in here. You can see just got our basic circuit again. We've got it compiled, and I also created a verification key, which you need to do in order to create the contract. So in order to make the contract, all you got to do is find where your circuit is. You should be in the directory with the Noir toml and type bb contract. And then we've got the contract, and this is our verifier contract, and we can deploy this. And this is what it looks like. This is maths, it's cryptography, and I do not understand it, but good thing is you don't have to. The only thing that's going to be of use to you here is a function called verify, which takes in the proof and an array of the public inputs. And then as long as like, if it does verify the proof, then it's good. And it will just terminate the transaction if the proof is not verified correctly. So yeah, return is true or reverts otherwise. So this is the only thing you'll ever really need to know. And you can just call this from another smart contract. So yeah, now that I've generated this contract, I'm just going to put this inside contracts in here so that my hard hat knows where it is. And yeah, I've just written this like simple counter contract, which pretty much all it does is it takes in the proof, takes in public inputs, and then it calls the verify function on this contract. And if that's all good, then it's going to like increase the counter by 1. So it's just an example of how it works. I've also written a test in here that you can have a look at. So I've copied this proof hexadecimal thing from what we did in Noir.js from here. And I've passed it to the verify function. Whoa, in our test, and then public inputs is the same. I just pasted that. Oh my god, pasted that as well. And yeah, this is just a hard hat test, so I don't think I really need to talk about this. But yeah, we're deploying our contracts and then sending the stuff here. So you can kind of have a mix of like you can do the proof in Noir.js, and then you can send that proof to a Solidity verifier on chain. So just make sure it works. If I run npx hard hat tests, awesome. So we've seen that our counter has gone up by 1. Just make sure that the test is actually working. This should fail. Nice. Cool. This is right on time. I have 45 minutes and it's been 45 minutes. So thanks guys. Appreciate you listening. I kind of want to share a few more things. So if you want to play around with Noir, and we've got some like really awesome primitives now in Noir that are super fun. So we have this thing called zk Passport. If you're a DevCon, you might have seen them around. They were they partner with DevCon, because if you like had a passport from Southeast Asia, you can get a discounted ticket without revealing any information from your passport except that it was from Southeast Asia. And they have an SDK, which means you don't even have to write any Noir. You can just write stuff in JavaScript. So there's a link to this in my slideshow I'll go to in a sec. But yeah, you can see some examples of how this works if you just want to explore this repo. What? Where is it? Here. Yeah, so we're just like importing ZK passport, and then you can do some various things here, which is pretty exciting. And you can prove anything about any passport. Some of them don't work. Like, I don't know if Indian passports work, or at least I think maybe only the really new ones do, and Palestinian ones don't work. And I don't think Aleph Man works either. But yeah, basically, like the way that it works is just through the signature that's on a passport, which is really exciting. So that's pretty cool. So if you don't want to play with Noir and you just want to use some sort of proving, you can do something with passports, prove that you're from Argentina, and then get into football club. You can put those examples together. And then this is also ZK email. So this you would be running with Noir. We don't have a JavaScript SDK for this one yet. But you can prove anything from any email, which is insane. Because if you look at an email, actually, I can show you one. How do I do show original? So this is what an email like actually looks like. And there's like signature stuff in here. And oh my God, this is a super long email. But if you look at the header, yeah, these signatures, you can basically like prove, especially this one, DKM signature, you can basically prove that it's true, and prove that it's legit and verified without any other information from it. So yeah, this is an example of one that's just like getting arbitrary email stuff. We've seen really interesting examples for it, like on and off ramping. So you can like prove that you've sent some sort of funds through Venmo or through some other app. You can prove it on email, and then you can get that like those funds on chain somewhere. So it's pretty exciting stuff, and it's kind of like a private way to do on ramping, which is cool. But yeah, so that's Noir. I hope this was somewhat helpful. If you have any questions, how do I stop? Sharing? If you have any questions, come into the Telegram, let me know. I'm going to be around. You can also like hit me up on Twitter. Oh, wait, actually, no, hold on. Also join our Discord. There's a QR code for that. We only let developers in, so if you're an airdrop.
Do you want to share the screen?
Yes.
Okay, a few minutes. Let me say it.
Thank you. Oh, yeah.
There you go.
This is our Discord link. If you want to join, we're always active in there as well, so you can ask some questions in there and on Telegram. And then these are just some of the resources. Actually, leave this on for a bit. And then, yeah, these are some of the resources that we talked about today. So this is the repo that we went through. You can just follow the instructions there. These are the Noir docs. And then this is the ZK Passport SDK example that you can look at. So, yeah. Thank you.
Thank you. What a great way to end this series of talks.
This is fun.
I really thank you for your time and for the workshop. And well, that concludes this series of talks of today. I want to say a big thank you to all the speakers. I want to say thank you to the audience for staying engaged all the day, basically, and to our participants of the Aleph de Verano Hackathon. Good luck and bye-bye.